चलिए just ठीक है, can you guys see the screen?
Yes, sir.
Yes, sir.
So I'm going to start the lots on WhatsApp, okay? So I'll start one by one, but let's start over here. Let's try and do these questions first. Just 1 second. Where's the So let's start with these ones. Just 1 second. Okay, so this question, you've got whatever this is. He's saying it's destroyed by hydrolysis with an acid. So the simplified structure of this thing is this. What are the products of its hydrolysis? So this is the simplified structure. So this is easy. You're hydrolyzing it. So I guess you're going to break the ester link, and this side will turn into a carboxylic acid, which is methylic acid. This side will turn into CH3 and OH. And so the answer would be, I guess it's going to be D. Okay, then there's another question, which is this one, that they're saying that there's this molecule 2-ethyl-3-methyl butanoic acid, which compound will produce this by heating under reflux, alcoholic sodium cyanide, NaCN ethanolic, and subsequent hydrolysis of the reaction product. Let me open the organic chart as well. Just 1 second. So what happens with NaCN ethanolic? That's the first question. Hold on a second. So this one, starting with NaCN ethanolic, that's nucleophilic substitution of a halogenoalkane. So we're going to do that first. And they're saying that you're supposed to make this compound, which is given over here. That's the compound you're supposed to make. So the Br will get replaced by CN. In all these cases, I mean, you'll have an H, and the Br will get replaced by CN. And over here as well, the Br will get replaced by CN, and this Br over here will get replaced by CN. What's the next part? Subsequent acid hydrolysis. What happens when hydrolysis happens? The CN over here gets converted to carboxylic acid. So all these CNs, they're going to change into COOH. This one would also change into COOH. Nitrile carboxylic acid. This nitrile also changes into carboxylic acid. So which one is the correct option? I mean, who's producing this molecule over here? I mean, you would have to compare everything. NaCN, CN changes, Br replaced with CN, and then hydrolysis, it changes into COH. So the answer, correct one would be, it's going to be B, because I think it's going to be B, because if you look at B, and if you look at this molecule, they're exactly the same. Look at the first part. You got 2 methyl branches on a CH. So you got.
इसका B है सर, इसका B है.
Let me check. I mean, I'm starting let's start with B, okay? I said 2 methyl branches on a CH, right? So this part is matching. Then you have another C. And this C, okay, so you got a C over here. This C has a carboxylic acid and it also has a ethyl branch. So there is C2H5 and there is a carboxylic acid as well on it. So this carbon atom, it's got ethyl, it's got a carboxylic acid. This one also has an ethyl, so it exactly matches this. What's wrong with C? What's wrong with C is that there's an extra CH2. That's what's wrong. Okay, there's supposed to be a carboxylic acid over here, which you have an extra CH2. Okay, Saad, is this clear? Okay, is this question clear? Okay, yes or no? Is this clear?
Yes.
So moving forward, we've got this question HCN, so it's turning into a cyanohydrin. The CN -1 with its lone pairs is going to get attracted to this carbon atom, and when it gets attracted to this carbon atom, the O turns into OH. So the middle carbon atom over here, this has OH as well as CN that's attached to it. So this is what's happening. So in a similar reaction, what they're saying is that this thing ion are generated by strong bases. Which compound can be produced from an aldehyde and this thing in the presence of a strong base? So the answer to this one is, now listen to this carefully. This is a nucleophilic addition they're talking about. The nucleophile is CN. That's your nucleophile. That's your CN -1. Now they're saying that there's a similar reaction, and that similar reaction has this nucleophile. This ion is generated, and they're saying what will happen if you have an aldehyde. So let's say I have an aldehyde. An aldehyde would be this thing. It's going to be serial bond O, and it's going to have an H, right? The reaction was that you have CN -1, it gets attracted to the carbon, which is slight positive, and the oxygen is slight negative. What happens in the next step that the C joins with the CN, you got an H, and on the top O turns into OH. Okay, that's the whole, it's a cyanohydrin that forms. So what we are going to do now is that they have stated that it's a similar reaction. And you don't have CN -1, you have this particular ion. So what I'm going to do is I'm going to replace it with this ion. So instead of CN -1, I've got CH2, CO2, and CH3. You can remember the focus is on the word similar, and it's got a -1 charge. They've stated that it's got a -1 charge. So the only thing would be that instead of the CN, you'll have this thing getting attached over here. So you'll have CO2 and CH3. So instead of the CN, you have this ion getting attached. So which compounds can be made from an aldehyde and this thing in the presence of a strong base? So you have to figure out which one is this compound. So you got, if I write it in condensed form, which one would be the correct option? It's going to be, you got a CH, you got an OH, and you got CH, CO2.
C.
Okay, so you got a CH, and with that CH has it has an OH attached, and it's got this CH2 CO2 attached as well. So if you draw the entire thing, just a second, if you draw the entire thing starting from this, so this one has an H, it's got an OH, and at the bottom it's got a CH2 CO2 and CH3 as well. And on the left side, it's got CH2, CH3. So this one exactly matches this structure over here, the one that we have drawn. It exactly
also the same, but it's just in reverse.
B?
Yes.
B is Just 1 second, let me just check. But C exactly matches this one, just 1 second. So C exactly matches this structure and it should be CH2, right? So what's wrong with B then? That you have so you've got CH3. Okay. As a B, you've got a CH3, you've got a CH, and it's got an OH as well. I'm drawing it in reverse. You got a CH, it's got an OH as well, and you got a CH2, and then a CO2 and a CH3. So you got a CH2 and O2. I'm drawing it in reverse. C and CH3. But let me draw it the other way just very, very quickly. 1 second. I'm trying to draw B over here. And let's try and figure out what's wrong with B. CH3, CO2, CH2. Then I got a C with an H and an OH and a CH3. So both of these structures, they're kind of very similar. They're just rotated version. You got a carbon chain, so that's R. I mean, that's your R. This one also has a carbon chain, and that's your R, right? So that's the first part. Then you got a carbon, so they all have this carbon, and that carbon has an OH, this thing attached, and an H attached. So all three are attached. So both of them kind of look correct. Why is one of them wrong? And I guess B is wrong. There's a very minor difference between them. Why is B wrong? And let me just go through this very quickly. Hopefully you'll be able to understand this. They told us that that you had a carbonyl and CN-1 was getting attached to it, and it turns into a cyanohydrin. That is what happens. But they specifically told us that it's an aldehyde. So that means the carbonyl would be at the end of the chain.
Tertiary alcohol ban raha hai na, sir?
No, you've got two options. One of them is C, the other one is B.
Okay, C and B.
D is not correct because this question is slightly difficult. Okay? Let me just go through this very slowly. Is the first part clear that they told us that there's a carbonyl compound and you've got it's an aldehyde or a ketone, or OH and CN get attached to it. Okay? So that's typical nucleophilic addition that happens, which is also shown over here. CN gets attached to it, and the top O becomes OH. So it's a typical nucleophilic addition. But then they say that it's an aldehyde. So that means this C double bond O, one side will be a carbon chain, the other side will be an H. And if you do nucleophilic addition for this one, so if you do nucleophilic addition for this one, there's going to be an H as well on that particular carbon atom, the one that forms a cyanohydrin. There's going to be an OH. And they told us that you don't have CN, you have a similar reaction. Instead of CN-1, you have this thing. So what I did was I just removed the CN because they said it's a similar reaction. And instead I added CH2, CO2 and CH3 instead of the CN. So my molecule should be this one. It should have a carbon chain on one side. This R is a carbon chain. It should have a carbon with OH, with H, and with this thing attached to it. And this is true both in C as well as B. In B, I've got this carbon. I've got this carbon over here in B. You got this carbon. It has an OH. It has an H. It has this entire CH3, CO2, CH2 attached to it, and it's got a CH3 carbon chain on one side, right? It's exactly the same structure. In C as well, I have exactly the same structure. I've got a C with an H. This particular C. It's got an OH. It's got a CH3, CH2 branch on one side. It's got CH2, CO2, CH3 on one side, right? So both of them give me exactly the same structure with one very small difference. What is that small difference?
Part B has a methyl in it, and
No, but
C has.
but remember, the methyl group is not important. It's supposed to be a carbon chain. It could be a small carbon chain. It could be a big carbon chain. So the methyl group, or you have an ethyl group, that is not an issue. Okay, the molecule must have a carbon. Yes.
OH group.
Both of them have an OH group. You've got a carbon which has an OH. This one also has a carbon which has an OH. This one also has a carbon which has an OH. So the
position of the OH and H group?
It's the same because I'm not drawing the three-dimensional. The position is exactly the same. They're on the same carbon atom. OH and H are on the same carbon atom. OH and H are on the same carbon atom. This thing is also on the same carbon.
So carbon attach होना चाहिए sir. B में hydrogen attach हो रहा है. तो उसको carbon पे lone pair है तो उसका attach होगा. I think.
First, I mean, clarify this. Everything is exactly in the same position, the way we have described it over here. The carbon, this middle carbon should have a CH3CO2 CH2. This middle carbon has CH3CO2. The middle carbon should have H, OH, and a carbon chain. The middle carbon has an OH, H, and a carbon chain. Everything looks exactly the same. So the very small minor difference is this one. Okay, the very small tiny difference is in this CO2 that's in the middle. And that's why this question is this is a very stupid question, because the difference is so minor that it's very hard to actually spot. So look at this chain and look at this chain. They're not actually exactly the same chain, because remember, you have a CH2. What's next to the CH2? I mean, if I were to draw this, I've got a CH2, and next to the CH2 I've got a C with two oxygens, C with double bond O, and then I have a CH3, right? So this is what's attached over here. Over here, I also have a similar thing, but it's not exactly the same thing. I've got a CH2. I mean, look at this carbon atom. I've got a CH2. So if I draw this over here, I've got a CH2. And next to the CH2, I don't have a carbon. I've got two oxygens. So that's oxygen. Then I have a carbon, right? And then CH3. So the structure of, it's the difference in the structure of this thing, that what should be next to methyl? It should be oxygens, not the carbon atom, which is why C is going to be wrong. Sorry, which one is going to be wrong? B is going to be wrong. Next to methyl, I should not have a double bond O. Like if you look at this,
paper में spot करना बहुत impossible होता है.
I mean, this question is like really stupid. I mean, it's the difference is so minor that it's very hard to actually spot this one. Okay, so B and C were kind of exactly the same. There was no difference. But did you understand the rest of the question apart from the last point? Okay, the difference between the two final answers were so minor. It was extremely minor that you got a methyl, and with the methyl you got an oxygen. So methyl, you have an oxygen, not a carbon next to it. So the ester link was actually inverted in both cases. That was the difference, which is why this one was the right option and not yes.
सर ये जो mass spectroscopy का टॉपिक है सर, ये सर कुछ लोग कह रहे हैं P2 में आ गए सर, तो P1 में कम चांसेस है सर, तो इसकी हम MCQs वगैरह कहाँ से करें सर? मतलब थोड़े बहुत तो हमें मिल जाते हैं, लेकिन मतलब
I'll go through mass. I mean, you wouldn't find MCQs for mass spectroscopy, not a lot of them. Okay, so I'll just go through mass spectroscopy again at the end. Okay, I will
show the first one.
सर mass spectroscopy questions आएंगे?
सर आपने वैसे वीडियो बनाई भी है सर उसकी, वो हम देख लेंगे.
हाँ, उसके बाद I've done a lot of questions. ठीक है, remember it's very simple. ठीक है, just keep it very simple. I mean, I'll go through those again. Yes, what's the
Sir, can you show the first one? The
option A?
No. The question before this one.
Okay, this one.
I'm kind of missed it.
I mean, there are lots of questions. Let's. I mean, it's being posted. I'll post it on YouTube again. So let's. This is the same question repeated. Let's do this one. You've got solutions of magnesium nitrate and barium nitrate separately undergo a series of reactions. M, N, and P are magnesium compounds. So M, N, and P are magnesium compounds. What is M? What happens when magnesium nitrate sodium carbonate is added to it?
Magnesium carbonate.
Okay, that's going to be magnesium carbonate. Remember, there's going to be a precipitation. Both of them are aqueous. That means in the solution, you have magnesium nitrate. So there's magnesium ions floating around. And sodium carbonate is also soluble. They don't have a typical reaction. They have precipitation reaction. Sodium carbonate is also soluble. So all these ions are going to mix up. But two of the ions will combine together to form something that is very insoluble, which is magnesium carbonate. So you'll get a solid precipitate of magnesium carbonate. And if you add it in excess HCl, that's going to be magnesium chloride. Carbonates react with acids. What's going to happen if you add NaOH to it?
Magnesium hydroxide.
Okay, another precipitation would happen because NaOH is also soluble. Magnesium chloride is also soluble. They don't react otherwise, but the ions will mix up and magnesium ions and OH ions will combine together to form insoluble magnesium hydroxide.
Sir, in the first part, won't sodium react with nitrate?
The sodium, even if it combines with nitrate, sodium nitrate is soluble. Group 1 compounds are all soluble. So sodium nitrate would dissociate and mix in the solution back again. So nothing new will be.
Carbonates of group 2 are insoluble.
Insoluble. So magnesium and carbonate, if they combine, they would permanently combine with each other. They would form a crystal, a precipitate would be formed. Is that clear? So if they were talking about the solution and they already told us that they are magnesium compounds. So we're interested in magnesium compounds. Although sodium nitrate will be formed, the solution will be sodium nitrate, but they're not talking about other compounds. Next one, barium nitrate, sodium carbonate. Will there be a precipitate?
Yes.
Okay, so there's there's going to be precipitate. Okay, but this is soluble. Barium and carbonate would combine to form a solid precipitate of barium carbonate, which will also react with HCl to form barium chloride. What happens if you add excess NaOH?
Barium hydroxide.
But that will not be formed. I mean, if you barium chloride is soluble, right? All chlorides group 2 are soluble. So barium chloride will dissolve. Sodium hydroxide is soluble. That's also going to dissolve. Now, none of them combine together to form something that is insoluble. They'll just remain mixed up in the solution because barium hydroxide is also soluble. NaCl is also soluble. So you'll just have a bunch of ions that are just mixed together. No precipitation happens. Is that clear?
Yes.
So, but he's saying that S is a barium compound. Barium chloride with NaOH. Barium chloride with NaOH. Nothing should actually happen. Then he says, how many MnP are white precipitate? So magnesium carbonate, right? That's insoluble, right? That's a white precipitate. Magnesium chloride, that's not soluble. That is soluble. It won't form a precipitate. Magnesium hydroxide, insoluble. That's a white precipitate, right? Group 2 salts are all white. Barium carbonate, insoluble. That's going to give you a white precipitate. Barium chloride is soluble. This last one is also soluble. No precipitation happens. So I guess the answer for this one is 3. You got a magnesium carbonate precipitate. You got a magnesium hydroxide precipitate. You got a barium carbonate precipitate, but no precipitation happens for the rest. Is that clear?
Yes.
Sir,
Can you explain it again?
See, just a second. But is this clear that the compounds that are getting formed? That when you mix.
Sir, I joined a bit later.
Okay. I'll just quickly go through this. Magnesium nitrate, if you react it with sodium carbonate, precipitation happens. Remember, there is no reaction of a carbonate with a nitrate. There's no reaction. Carbonates react with acids. Yes. Okay. If you have barium chloride and you mix it with NaOH, now a base does not react with, what does a base react with? It reacts with acids, right?
Yes.
A base reacts with ammonium salts, but it does not react with the chloride, right? So there is no typical reaction. So what happens? Barium chloride is soluble. So it's going to mix, it's going to dissociate. When something is soluble, it dissociates into its ions. The ions get scattered in water, right? If NaOH is aqueous, that's also soluble. Group 1 salts.
Soluble नहीं है तो वो precipitate क्यों नहीं form कर रहे?
These are soluble. Barium chloride is soluble. all group 2 chlorides are soluble. So they will dissociate. They will get scattered. When you mix them in water, their ions will get scattered in water. NaOH is also soluble. So its ions will also get scattered in water, right? So NaOH is soluble, barium chloride is soluble. So think of it as ions mixed in water. Do any of the ions combine to form something that is insoluble? Na could combine with Cl, but NaCl is soluble. So it will remain dissolved. Barium could combine with OH, but barium hydroxide is also soluble. So that will also remain dissolved. So no precipitate forms. Nothing insoluble is getting formed, right?
Yes. Okay.
As the next one, you've got
So,
yes.
so does this have to do something with the solubility increasing down the group?
But you have to know that barium hydroxide is soluble, magnesium hydroxide is not soluble. So in this one, there's going to be a precipitate. Like if you mix magnesium chloride, which is soluble, so its ions get scattered in water. You mix it with NaOH. Now they don't have any typical reaction, but magnesium ions and OH ions will combine, and they will form an insoluble precipitate of MgOH2 because it's insoluble. I mean, that's why precipitation is happening, because MgOH2 is insoluble. As the next one, how many of the following compounds produce a carboxylic acid on heating and the reflux with an excess of hot acidified K2Cr2O7? So
The answer 3.
under reflux, so you're oxidizing it, right? So first one, will it produce a carboxylic acid?
Yes.
Yes.
Second one.
No.
No.
That's a ketones.
No.
This one, third one,
Yes.
Yes.
and the fourth one.
Yes. No.
No.
No, that's a secondary alcohol. This carbon has 2 carbon chains attached to it, so that's a secondary alcohol. So the answer is going to be B, right? It's going to be 2 for this. Now, this one, is this clear?
Sir,
Yeah.
for the last question, what is the second one you chose?
What was the?
What is the second one you chose? Like other than the aldehyde?
You're talking about this one. It's a ketone. The second one, this is a ketone.
Sir, the next one.
The third one,
Yes, sir.
that's an alcohol. That's a primary alcohol. Primary alcohols, they get oxidized to carboxylic acids. The OH is at the end of the carbon chain. It's this one is a primary alcohol. So yeah. So then move to the next one. Sorry. So now moving to the next one. So this one is a slightly difficult question. He's saying that there's this molecule which is that's the name. It can be synthesized by reacting this thing with NH3. So you've got a halogenoalkane. So you got this halogenoalkane. It's reacting with NH3. What happens when a halogenoalkane reacts with NH3?
Amine.
The amine is formed.
So it's going to be an amine, right? So this is what happens that I'll give you an example. You've got CH3, CH2 and Br. What will happen? The Br will get replaced by NH2, right? That's nucleophilic substitution. Now the question is, which one of them will undergo this reaction? You're going to react it with ammonia and this is produced. So you're going to react it with ammonia and this molecule is produced. And one thing that you should notice is usually what happens, one Br gets replaced by one amine, right? But over here, one ammonia is replacing how many bromines? 2 of them. So it's replacing 2 of them. So if I go back, if I do the reverse, so remember this point that one ammonia is replacing 2 2 bromines. So if I do the reverse, get rid of the amine, put the bromines back in. So here's the amine, right? So what I'm going to do is I'm going to do the reverse. I'm going to get rid of the amine. Where should I put the bromines? The bromines are going to be put at the same point, right?
Yep.
It's going to be this carbon atom and this carbon atom, right? So the 2 bromines would be over here. So this is basically what happens. All you had to do was, I mean, you already know this fact that a bromine gets substituted by amine, right? But if you look at the equation, the ammonia is actually substituting 2 bromines. So if you do the reverse, get rid of the amine and put the 2 bromines back in their place. So you'll get this molecule. Is this clear?
Yes, sir.
So the cyclic structure breaks?
Okay, so the cyclic structure kind of breaks. So basically it was like this. It was, you had 2 carbon, I mean, you had this molecule, right? You had a bromine over here and you had a bromine over here. Did I draw this right? It's 1, 2, 3, 4, 5. And you got CH2 and CH2 and CH3. So this is what was happening. And ammonia came along. The carbons were positive. The ammonia had lone pairs. And what happened was both of them got attracted to the lone pairs on amine. And as a result, both bromines, they got repelled and they broke away. So one ammonia actually ended up replacing 2 bromines. So I did the reverse, and that the hint was given in the equation over here. The ammonia was replacing 2 bromines. So if you want to go back, get rid of the amine and put the 2 bromines back in there. So what's the name of this molecule now? That's the last part.
There are 8 carbons and
Okay, so
One
that's
side dry
I think it is D.
bromo.
okay, 1, 2, 3, 4. Let me just 5, 6. So 8 carbons. So that's octane, right? And one bromine is on the
1,
first one.
5.
1, 5. So it's going to be D, right?
Sir,
So yes.
sir, एक सवाल था सर. सर आप ये
हाँ.
बता दें सर, how is electrophilic addition a redox reaction?
It is a redox reaction because as I make sure a lot of reactions are actually redox reactions. Make sure remember this, that is the oxidation state changing or not? You have Br2. What's the oxidation state of Br2 right now?
0, 0.
When it forms a compound, what's the oxidation state of Br?
-1.
So it is a redox reaction.
और सर oxidation कहाँ हो रही है?
इसके अंदर I mean the carbon I'll explain. So at the moment, now if you just a second. So the point is, remember, finding oxidation states for organic compounds is very difficult. Okay, because each carbon is behaving differently. But so I'll use electronegativities, right? The electrons over here are closer to which atom? I mean, in this one is symmetric. Both carbons are exactly the same, so we can do it the old-fashioned way. What's the oxidation state of carbon at the moment? That's 2x plus 4h, and the whole thing is 0. So x would come out to be minus 4 divided minus 2, right? So right now it's -2. Then the 2 bromines get added to it, C2H4, and now it's Br2, right? So the carbons are again 2x. The hydrogens are +1 into 4, so that's +4, and the 2 bromines are -1 into 2. So what's the value of x now?
-1.
-1, right? So that means carbon got oxidized. It had an oxidation state of -2, and that is increasing. It's now -1. Is that clear? So carbon is getting oxidized, and bromine goes from 0 to -1. Is that clear?
Yes.
But remember, for organic compounds, just be careful with organic compounds that it's very hard. Like if you have a bigger molecule, The reason I took the two carbons having the same oxidation state in this case was that they both were identical. But if the carbons are not identical, like in this molecule, you got a carbon with 3 H's, you got a carbon with 2 H's, you got a carbon with carboxylic acid. So all these carbons are not exactly the same. So you can't figure out the oxidation states based on this method, because every carbon will have a different oxidation state. This would be X, this would be Y, this would be Z. So there would be too many unknowns. You wouldn't be able to figure out the oxidation state. So questions like these they won't give you a question like these. For example, for this molecule. Even the question about redox, that was just for you to guess whether it's a redox or not. So remember in organic chemistry, gain of hydrogen and loss of oxygen and gain of oxygen, that's a much better way of figuring out whether it's oxidation or not. Is that clear? Instead of oxidation states, because oxidation states are harder to calculate for organic compounds. Now, this question. There's the concentration of blood glucose is measured in millimoles per liter. In Pakistan, the concentration of blood glucose is measured in milligrams, but I guess that's deciliter. What is DL? Yeah, deciliter. So blood glucose concentration of 18.5 millimoles per liter indicates a health problem. What is this converted to? So that's more like a physics question. So you just have to convert this. First thing, convert this to grams. Milli is 10 power minus 3 moles, right? So I've got 18.5 into 10 power minus 3 moles multiplied by the MR of glucose, which I guess is 180. So how many grams do I have?
$3.33.
So it's 3.33 grams, right? Convert that to milligrams. How do you convert that to milligrams? Because the answer should be in milligrams per deciliter, right?
Divide by 10 raised to the power minus 3.
D.
10 power minus, divide by 10 power minus 3.
D.
It's, so what do you get if you convert to milligram?
D.
D.
We have to convert the there's another step as well. We have to convert the decimeter thing as well, or deciliter thing.
2,330.
Is this for this one?
Yes, sir.
That's the milligram, right? But that's per liter now. Now we have to give the answer over deciliter. So convert 1 liter. How do you convert 1 liter to deciliter? That's 1 liter has how many deciliters? That's 10 deciliters, right?
Yes.
So the answer would be C then. And the first thing was I converted the grams to milligrams.
I didn't understand this part.
Did you understand the first part, right? It's 3,330 milligrams, right? Is that clear?
What?
Is the first part clear?
No, can you re-explain it? Why did you multiply it by 180?
Let me explain the whole thing, right? So it's 18.5 millimoles per liter, right? So 18.5 millimoles. That's 18.5 into 10 to the power minus 3, right? Because it's millimoles. Milli is 10 power minus 3, right? So it's 18.5 times 10 power minus 3 moles. Multiplied by 180, which is the MR, you get the mass, which is 3.33 grams, right? Now, so I figured out the grams, but they were asking for the answer in milligrams. So what is 3.33 grams in milligrams? In milligrams, it's going to be, you divide by 10 power minus 3. So it's going to come out to be 3,330 milligrams. Is that clear?
Yes.
Yes, sir.
So that's the first part. So we figured out the milligrams. It's 3,330 milligrams if you convert 18.5 millimoles. Divided by liter. right? So that's, this thing should be divided by 1 liter. That's 18.5 moles. That's this many grams per liter. So that means 1 liter. So 1 liter has how many deciliters? They've told us that this one, I probably did not do this one right. So liter, they've already told us that's 1 dm cube. So how many deciliters would 1 liter have? One, like over here, 1 liter.
Could you please explain this again?
Okay, I'm doing this here now. It's 18.5 millimoles over 1 liter, right? Is that clear, this part? Okay, so we have to convert that into milligrams per deciliter.
Sir, in the last part, 330 mg, are we going to multiply it by 0.1?
Yeah, you're going to do that. Or divide by 10. So let me do this over here. So that's millimoles. Millimoles should be, the top one should be converted to milligrams. I mean, they're looking for the answer in milligrams per deciliter. So I'm converting the numerator to milligrams. So milli is 10 power minus 3 moles multiplied by the MR, which is 180. That gives me grams. How do I convert grams to milligrams? So this thing, I'm not sure about this one. Is this clear to, is this done right? How do you convert grams to milligrams?
Divide by times 10 to the minus 3.
Oh, okay, that's fine. That works. Okay. So you're basically multiplying it by 10 power 3. So now the whole thing is in milligrams. Now you have a liter at the bottom, right? And they've told us that 1 liter is how much? It's 1 dm cube. They want the answer to be in deciliters. So what's a deciliter? How many liters would it have? It should have 10 deciliters, right?
Yeah.
Is that clear? I mean, this clearly states that 1 liter has how many deciliters? That's 10 of them, because 1 deciliter is 0.1 dm cube. So 1 dm cube will have 10 of them. So if the denominator is 1 liter, so in deciliters, it's going to be 10 deciliters. So I basically converted the units. The millimoles have been converted to milligrams, and the liter at the bottom has been turned into deciliter. 1 liter is basically equivalent to 10 deciliters. So I've converted the units. The only thing is now it's milligrams over deciliter. So I just need to simplify this now, and that would give me C. Is this clear?
So the liter and deci, whatever is confusing.
This one?
Yeah, because it says there's 1 dm cube and we have 1 liter. So why wouldn't it be 0.1?
No,
dm
1
cube?
liter is the same as 1 dm cube. The unit L is a liter, which is basically 1 dm cube.
So why don't we just put 0.1?
No, because the bottom over here, look over here. What's in the numerator? Sorry, denominator over here. It's 18.5 millimoles over a liter, right?
Yeah.
So you're gonna keep it a liter. What's the equivalent of a liter in terms of decimeter? I mean, you're not going to change the value at the bottom. What is 1 liter equivalent to in deciliters?
0.1.
No. See, there's 1 dm cube. That's 1 liter, right? And there's 0.1 dm cube. That's a deciliter. So what is 1 liter equivalent to? That's 10 deciliters. Is that clear?
Oh yeah.
So I'm not going to change the value. It's 1 liter. I'm going to keep it as 1 liter, but I'm just expressing it in deciliters now. Is that
But
clear?
wouldn't 0.1 times 10 be 1? Wouldn't 0.1 times 10 be 1?
Yeah, 0.1 dm cube is basically a deciliter, right? So I've changed the unit. A deciliter is 0.1 dm cube. So I'm not using 0.1. I'm using 10 deciliters. they didn't want the unit to be in dm cube. They just want I mean, think of this again. It's 1 liter is 1 dm cube. A deciliter is 0.1 dm cube. So what is 1 liter equal to? That's 10 deciliters. Is that clear?
Yeah.
I mean, if you so that's 1 liter, which is and you've got 1 deciliter. So what's the equivalence? This is 0.1 dm cube. This one is 1 dm cube, right? So the equivalence is that it's equal to 10 deciliters, right? So instead of 1 liter, I'm just putting in or placing in 10 deciliters. So you're not going to change the value. I'm not going to change the value. I'm going to express the whole thing in a different unit. I'm going to express the whole thing in a different unit. And anyways, if I solve this, that's going to give me this thing. Okay. I said now the next one. You've got I saw this one. The cracking of a single hydrocarbon produces 2 hydrocarbon molecules only. Each hydrocarbon product contains the same number of carbon atoms in 1 molecule. Each hydrocarbon has non-cyclic structural isomers. What is the value of N? So there's a hydrocarbon, which is CnH2n plus 2. It's being cracked into 2 pieces. And each product contains the same number of carbon atoms. So they have the same number of carbon atoms. So what does that mean? Do you have an even number of carbon atoms or an odd number of carbon atoms?
Even.
Even.
Even, because if you have 3 carbon atoms over here and 3 carbon atoms over here, this one will have 6 carbon atoms. You can't have odd numbers. So it's either going to be 6, it's either going to be 4. You might have 2 carbon atoms in this one, 2 carbon atoms in the other one. So it would be 4. So whatever happens, the original molecule can only divide into 2 equal parts if it's even. That's the first thing. So it's got to be even. But then he says that each of the 2, each hydrocarbon product, I mean, either we're talking about X or Y, they have non-cyclic structural isomers. So can you have non-cyclic structural isomers if you have 4 carbon atoms in the original molecule?
No.
Because this will have 2 carbon atoms, this will have 2 carbon atoms. There's no way to arrange 2 carbon atoms in a different way. You can't have structural isomers with just 2 carbon atoms. Is that clear? Can you have non-cyclic structural isomers with 6 carbon atoms? If the original molecule has 6 carbon atoms. 3 carbon atoms, 3 carbon atoms. You can't rearrange 3 carbon atoms. That's it. That's the only arrangement. You can't really have isomers in this. So the answer is going to be 8. Because if you have 8 carbon atoms, 4 carbon atoms, 4 carbon atoms, now you can have isomers. You can either have all 4 of them in a straight chain, or you can have 4 of them in a branched chain. So the answer for this one is 8. Is that clear?
Yes, sir.
So what about C?
The answer is C. ठीक है, C.
Sir, why not
No, I
4?
mean like 6, sorry, 6.
No, with 6 you can't, because if you have 6 carbon atoms, it's going to be 3 carbon atoms and 3 carbon atoms, right? Can you have structural isomers with 3 carbon atoms? You can't. Like, how can you rearrange 3 carbon atoms? There's no other way of rearranging them. Is that clear?
Yes.
Because questions clearly stated that each hydrocarbon product has non-cyclic structural isomers, right? Achha, theek hai, ye clear hai? Achha, now I'm just going to be copying questions from WhatsApp now. Just one second.
Sir, I have also sent you those questions, so if possible, can you do them?
So send me again. Put a star and send that star so that you're. I mean, I've got a lot of questions, Tika. So just 1 second. Let's start with this one and hold on 1 second.
So, you know, in past papers, how there's a section B, should we still attempt that or should we not? Like just for practice today?
Just for practice, you should.
Okay.
ठीक
thank
है, so
you.
this one. So we've got this question. Probably looks like an easy question. You got a metal has a total surface area of 150. So it's got. It's. Let me just 1 second create another board.
सर मैंने भी आपको क्वेश्चन भेजा था, वो भी सॉल्व कर दीजिएगा काइंडली.
ठीक है. I saw this one first one quickly. He's saying there's electrolysis and silver is being coated. So there's a coin, I guess, a metal, right? And silver is being coated. So how many atoms of silver were deposited per centimeter square? So it's 0.216 grams. So how many moles of silver is that? That's how many moles is this? 0.216 divided by the AR of silver. What's the AR of silver? That's 108. Is it? I guess it's 108. So how many moles is that?
2 into 10 raised to power minus 3.
So that's 2 into 10 to the minus 3 moles. The next thing is he's asking for the atoms. He's asking for the atoms of silver, right? So how do you figure out the atoms? That's multiplied by the Avogadro's constant. That's 10 power 23. What do we get for this?
Mm. 1.204 into 10 raised to power 21.
And these atoms of silver have been deposited over 150 centimeters square. So that was what they were looking for per centimeter square, the number of atoms deposited per centimeter square. So what's the answer to this?
8.0. Yeah.
Okay, so we would do it with the moles. I thought we just do it. All right.
With?
I did it. I just did 0.216 over 150 directly.
You had to count the number of atoms. Okay.
Yeah.
So next one, 1 second. So this one, I'll just do it over here. That this one has been frequently done. That's ethanol, and the reaction mixture is boiled and reflux for 1 hour. So that means it turns into.
Sir, I asked you another question right under the. Could you do that?
Okay, just a second.
Yeah, you can do this first.
So this one, so it's CH3 CH2OH, and there's a sample, and it's going to turn into carboxylic acid. Obviously, CH3 COH. It's being boiled under reflux for 1 hour. It's 2.3 grams. How many moles is that? That's divided by the MR 46. So what do you get for this? 0.05 moles. So the ethanoic acid would be 0.05 moles as well, because it's 1:1, multiplied by the MR, and that's going to be 60 for this, and that's going to give you 3 grams. And so theoretically, you should get 3 grams, but the yield is 60%. So you're not going to get 3 grams. You're going to get 60% of this. Okay, so you're going to get 60% of this. So 60% of this is 1.8 grams. Okay, just
Can you repeat this one?
now you had ethanol 2.3 grams. How many moles is that? That's divided by 46. That's the MR of ethanol. So that will give you 0.05 moles. Now ethanol getting oxidized turns into carboxylic acid. So 1 mole produces 1 mole. 0.05 moles will produce 0.05 moles. Find the mass. How do you find mass? You multiply it by the MR, which is 60 in this case. So you're going to get 3 grams. Now that's your theoretical. That's your theoretical. That's the one that you're getting on paper. When they say that the yield is 60%, that just means that you're not going to get this. You're going to get 60% of this. and 60% of this is 1.8 grams. ठीक है, is that clear?
सर इसके अंदर मुझे एक चीज था सर, क्योंकि हम अगर एथेनॉल को हम ऑक्सीडाइजिंग एजेंट के अंदर डालेंगे और उसने लेकिन आगे लिखा हुआ था कि इसको हम डिस्टिल करते हैं और मतलब फ्रैक्शनल डिस्टिलेशन, तो हमें एथेनॉल नहीं मिलना चाहिए?
नहीं, फिर एथेनॉल you should get ethanol, but ये देखो ना, if you're refluxing it for 1 hour, तो सारा काम तो हो गया ना, everything is done. You're refluxing it for 1 hour. So the reaction is going on for 1 hour. So the distillation at the end, because it's this thing, right? It's, you got a primary alcohol, it turns into an aldehyde, and it then turns into carboxylic acid. Now, the only way you can stop at an aldehyde is that if you immediately distill. Is that clear?
ठीक है सर, तो अगर हमें ये कहता है कि it is refluxed and fractionally distillated, तो फिर हम इथेनॉल का करते हैं?
Then you would have gone for ethanol. There's another question similar to this where they do immediate distillation. Okay, so you only get aldehyde if you do immediate distillation. Because if you're heating it for 1 hour, then the whole thing is over. It's already a carboxylic acid. So there's no point of distilling it after 1 hour. Okay?
Also सर वो इससे तकरीबन रिलेटेड ही है, वो ये जो होते हैं, तो हमारे पास दो ऑक्सीडाइजिंग एजेंट्स हैं, एक तो कॉन्सेंट्रेटेड हॉट एसिडिफाइड पोटेशियम डाइक्रोमेट है और एक पोटेशियम मैंगनेट है। सर इनमें से स्ट्रॉन्गर और वीकर से कोई फर्क पड़ता है कि हमारे पास प्रोडक्ट क्या आएगी या नहीं?
I'll just go through this. Okay? Just remember that that for alcohols and aldehydes, just a second, let me. I said, remember for this one, for alcohols, aldehydes, the preferred one is K2Cr2O7. That is slightly weaker. That's the preferred one. KMNO4 is not preferred, but KMNO4 does the same thing. Okay, so if you were to write the answer for this, it should be K2Cr2O7. For alkenes, remember alkenes oxidation, it doesn't work with K2Cr2O7. That one only works with KMNO4. That's it. Okay? Yes. There's
a question in February, March 22, and there was a question related to empirical formula that could not be solved like by a normal equation.
Consa, what's the question number? It's just 1 second. Let me solve this one first. So just one very quickly. So I'm going to do this here as well. Just a second. So this question, you probably can't see this on the screen. Just a second. That's now. I saw this question. You got a mixture of gases consisting of 12 grams of hydrogen, 42 grams of nitrogen, and 4 grams of helium. What is the mole fraction of hydrogen in the mixture? So that's, find out the moles. 12 grams of hydrogen, that's 12 divided by 2 mR. Right? So that's the moles. How many moles? That's 6 moles, right? 42 grams of nitrogen. So how many moles is that? That's 42 divided by nitrogen is N2. Remember the gases. So he's talking about N2. That's 28. So what do you get for this? That's 1.5 moles. You please confirm, TK. And you've got 4 grams of helium. So how many moles is that? That's 4 divided by 4, I guess. That's 1 mole. So mole fractions. You got 6 moles of H2. And you've got 1.5 moles of N2. And you got 1 mole of helium. So mole fraction of this thing, it's going to be 6 divided by the total, which is 8.5. Okay, that's the mole fraction. Moles of H2 divided by the total moles, which are these.
So why did you take them as diatomic?
Yeah, because as a gas, this is going to be H2. This is going to be N2. This is going to be helium monatomic.
So, sir, why do you divide it by like 2?
Because it is diatomic. Hydrogen is H2. The molecule of hydrogen is H2. It's not. Hydrogen is diatomic. Remember this, that whenever hydrogen, oxygen, nitrogen, or group 17 compounds are mentioned, they're all diatomic. Like if they talk about chlorine, they're not talking about a chlorine atom, they're talking about Cl2. Is that clear? So the MR of hydrogen is 2, it's not 1. Okay. So just a second. Next one is next one is
Sir, just a second. You said we're going to divide third by 2. So we're going to multiply MR of nitrogen by 2 as well, right?
We did that. 42 divided by 28. Okay. 20, nitrogen is 14, but we actually took it as 48. So just let's try these ones. 1 second. So these ones. So we've got diagram shows a simplified mass spectrum. Now that's which equation represents the process that produces the particles responsible for the peak at 57. Now this is a mass spectrum question specifically. So I'll just go through mass spectrum very quickly. You got pentane 3-one, right? What is pentane 3-one? That's serial bond O, C, and CH3, right? So that's CH2, and I've got another CH2, and I've got a CH3, right? So this one. What happens in mass spectroscopy? The basic idea is you bombard this molecule with electrons. You try to turn it into ions. So there'll be a molecular ion, which is that the whole molecule would be intact, but somewhere, someplace, an electron would be lost. So this entire big molecule is going to turn into an ion, or it would turn into fragments. It will break down into small, tiny pieces, like a CH3 fragment can be produced, or a CH3 CH2 fragment could be produced. So this entire molecule will break down at any point, right? Maybe a CH3 CH2 CO fragment could be produced. Is that clear? That you'll have a big molecule, that's your molecular ion. And then you've got lots and lots of fragments. And these are turned into a beam and they're deflected. And the deflection is inversely proportional to mass. So by looking at the deflection, you're able to figure out the mass of the particles. Okay, that's how you figure out the relative mass. If something is heavy, it will be deflected less. If something is light, it will be deflected more. So you get all these fragments. Now he's talking about 57. He's saying that there is a detection that's happening. There's a particle with a mass to charge ratio which is 57. So it has a mass of 57. So which fragment do you think has a mass of 57? Like lots of fragments. What is CH3? Like a CH3 fragment could break out of this molecule. What is CH3? That's 15, right? Or maybe it's a bigger fragment. Maybe it's CH3 CH2. What is CH3 CH2? That's 29, I guess. We need a bigger fragment. What is CH3 CH2? And we can include the CO as well. That could be a fragment.
That's 57.
That's 57. So that means this fragment is getting produced, right? So this big molecule over here is breaking down. And if it breaks down at this point, what's the other fragment that's going to be produced? That's going to be CH2, CH3. Is that clear?
Yes.
So the molecule, which is, which one is the molecule? Which one is the correct option now?
It's either A or B.
A.
A and B are kind of similar, but A, this is the free radical, and you have this one.
Is it A?
Just once again, A or B. The only difference between A and B is that since it's going to be A. Why is it going to be A?
There's a positive charge with it.
Because if this is being detected, right, 57 is being detected, the only particles that are detected in a mass spectrum are the ones that have a positive charge on them. Is that clear?
Not the radicals?
So
No, the
we're
because
going to calculate the MR of CH3, CH2, CO.
Because these are fragments. Remember that you have a big molecular ion, so you have a big particle getting detected, and you have lots of tiny particles that are getting detected. The big particle is probably 86, the one that is detected over here. I mean, this whole entire thing has a mass of, I guess it's 86. 29 plus 29 is what? That's 58. 58 plus 12, that's 71. Plus 16, that's I think that's 86.
So like we have a ketone here. So you told us how we're going to divide a ketone. But what if there are other groups like carboxylic acid?
Cassius, I can't hear you properly.
So you said we're going to divide it from like carbon alpha, right? For ketone. What if there is
I didn't. The reason is that they're saying that there's a particle that is getting detected at 57, right? So I have to figure out what is that particle that's being detected at 57. I mean, that's what I'm trying to find out, right? So, just a second. So that's what I'm trying to find out. I first divided it over here, CH3, and I couldn't get a particle that had a mass of 57. Is that clear? So I did trial and error, and then I figured out that if the molecule breaks down over here, then I'll have a particle that has a mass of 57. I'll have another particle that has a mass of 29, right? Actually, which exactly matches what's happening here. But since they're exactly saying that the particle at 57 is being detected, any particle that gets detected on the mass spectrum, it should have a positive charge. Because in the mass spectrum, deflection is not possible for a neutral particle. Because why do particles get deflected? Because they're positive charged particles that enter a magnetic field. Now, they would only get deflected if they have a charge. Charged particles, they get deflected in the magnetic field. If they don't have a charge, they will not get deflected, and they'll just keep moving straight through the magnetic field. Is that clear?
So radicals don't have a charge?
Radicals don't have a charge. I mean, if they had a charge, they can have a charge, but this one doesn't because they didn't write a charge with it. If it had a charge, they would have written a charge next to it.
Okay.
Sir?
Yes.
Sir, I sent you the question.
Yeah, just a second. Let me first.
Sir, मैंने भी भेजा हुआ.
एक second. What is this one? Which does not represent a process that produces a detectable ion? Now, same question. Detectable ion in a mass spectrum. So for an ion to be detectable, so remember, a molecule will break down into many small fragments, right? So does not produce. This is going to get detected, right? This is going to get detected, positively charged. Who's not going to be detected?
Chlorine.
C,
because negatively charged particles are not detected. Helium +1 is obviously going to get detected, but C is not going to get detected. Only positively charged particles are detected in the mass spectrum. So next is, so these are all mass spectrum questions, so these are important. What is the mass to charge value of a significant peak found in the mass spectrum of a propanol and not found? Now this one is interesting. Make sure you find, I'll post the video on mass spectrum. There are lots of questions done. They're not MCQs, but they're very similar to these questions. You've got CH3 and you got CH2 and CHO, right? That's an aldehyde. What is this one? That's a propanol. So that's a Cl bond O in the middle and CH3. Now, both of them have the same molecular ion. The molecular ion has the same mass. Remember, the mass spectrum does only differentiates a molecule based on its mass, because the deflection is happening because of the mass. Lesser the mass, more deflection.
That they both have the same mass?
Because they have the same formula. I mean, this is C3860 and this is also C3860. Okay, so they have exactly the same formula. I said now this one quickly. the molecule will break down into many fragments, right? There's going to be a molecular ion, the whole thing will get detected. C3H6O, whatever the mass is, there's going to be a particle with that mass getting detected. Which particle will be detected or fragment will be formed in this one and not in the other one? And remember, what would be the
CH3.
One second. CH3 will be formed in both of them. Like if you look at CH3, I mean that particle can be the fragment can be formed in both of them. Is that clear? So 15 is not the answer. You'll detect a particle with the mass of 15. You'll also detect a particle with the mass of 15 in the other one. CHO is the one. That CHO
29.
is 29, right? No matter how you break this molecule up into pieces.
So why is it not detectable?
It's going to be detected in this one, right? Because the CHO fragment will be detected, right? Can you break this down into a fragment that has a mass of 29? Like if I break it down into pieces, I'll have one fragment that is 15. What's the other one? That's 15 plus CO, which is what? A lot higher than 29, right? Even if I break it down into 3 pieces, even then I'm not going to get 29. I'll get 28, but I'll not get 29. So no matter how I break this molecule up, I'm never going to get a fragment that has a mass of 29. Is that clear?
What about CH3,
Yes.
Which one?
CH3, CH2. The other one doesn't have that either.
And that is also 29 actually.
Oh.
Because this one has this one, right? What is the mass of CH3, CH2? That's again 29. So you'll actually detect 2 types of particles. Remember, the mass spectrum is not able to differentiate the structure. It only, the mass spectrum would think it's the same particle because it's going to detect both of them having a mass of 29. So the detector will detect both of them at the same point. But this one does not have either of them. It's never going to form a particle which has a mass of 29. Is this question clear?
Yes, sir.
Yes.
To get to the next one. 1 second. So again, another one. We've got this one. We've got whatever this is, BCF, bromochlorodiafluoromethane, right? What's bromochlorodiafluoromethane? That's what is that? That's bromo.
Two fluorines, one Cl, and one Br.
So hello, can you guys hear me?
Yes, sir.
Yes, sir.
So just a second, sorry, got disconnected. कहाँ पे थे? So we were somewhere here. Just 1 second. See this one. We are already done this one. Just hold on 1 second. Let me. So we had done this one, and we had done this one, and this one. Now, okay, we on this one. Now, in mass spectroscopy, I had another question about which was about bromine and chlorine. Do you know how many isotopes does bromine have? I mean, this is something. 2 of them. What are those 2 isotopes? One of them is
79, 81.
And 81. What is the percentage abundance of both of them?
50.
50%.
It's equal percentage. So basically, if you were to detect any of those particles, there would be an equal probability. You'll detect equal number of particles, right? So that means this graph is fine. That it was bromo, chloro, difluoromethane, right? So bromo, one chloro, and difluoromethane, right? So if you were to detect this bromine fragment will be detected, right? But there would be 2 types of bromines. They would have 2 different masses. You'll detect a particle with a mass of 79, and at the same time, you would also detect a particle with a mass of 81, and they would have equal abundance. Let's say you detect 10 of these, you'll also detect 10 of these as well. There's equal probability, right? So does this graph, I mean, this graph probably looks correct. Is that clear?
Yes.
But what if
So
you
what
told
about
us to
CND?
detect Cl?
What if they?
Or how are we supposed to know that bromine has an isotope mass of 79?
This is something you have to remember in mass spectroscopy. Okay, this is something you have to remember, that bromine has 2 isotopes, and you also have to remember for chlorine as well. You have to remember this for chlorine, that chlorine has 2 isotopes. One is 35 and the other one is 37. But in this case, the probability is around 75% for this one and 25% of this one, which is 3:1. So
why wouldn't B be correct?
why wouldn't B correct? Because if you were to detect a particle with a mass of 79, this bromine has a mass of 79, or it has a mass of 81. There's going to be equal probability. Like if you detect 20 bromine atoms, right? So 10 of them would be 79, 10 of them would be 81. Do you understand the point?
Would chlorine be 35 and 37 then on this B graph?
Okay, so if you were to detect a chlorine fragment, right? Now chlorine would be detected at a mass of 35 or at a mass of 37. Firstly, there is no 35 getting detected. There's no 37 getting detected, right? So, I mean, chlorine is not an option over here. Is that clear?
Yes, sir.
Sir,
Yes.
what about C and D?
So now what's wrong with C and D? Now, is this clear about one bromine, right? Like if you have one bromine, right? It's either going to be 79 or it's going to be 81. Now, 2 bromines is not in your course. 2 chlorines is not in your course. But let me just, we're not actually sure it's in your course, but it's not in your syllabus. It used to be, till the last exam, it used to be in your course. But they've now actually taken that out. I said they've now actually taken that out of the course, but I'll just briefly tell you, okay, don't do it. I mean, don't go into that. It's better not to go into that. It's no longer mentioned in the syllabus. So I will now explain why this would be wrong. how do you get 160? For 160, the molecule should have at least 2 bromines. Because if you have 2 bromines, one of them is 79, the other one is 81. Then you're going to get a particle with a mass of 160, or maybe 162 as well, because you might have 2 bromines. If it had 2 bromines, then it would be 81 plus 81. So if the molecule has, or the fragment has 2 bromines, then it's going to be 162. But the problem is that in any one of the molecules, there's only 1 bromine. So the fragment that's going to be produced would be a single fragment of a single bromine. And that would either have a mass of 79 or 81. It can't have a mass of 160 or 162. Is that clear?
Yes.
So just one second. Let me just go through these questions first. And let me clear this. So we've got this one. There's a molecule. We did what volume? First thing, citric acid. This is citric acid. How much NaOH should react with it? What will the NaOH react with? Would it react with the carboxylic acid? Would it react with the alcohol?
Or NaOH?
No.
No.
So the alcohol is not. So there's one carboxylic acid that needs one NaOH. There's going to be another NaOH reacting with the other carboxylic acid, and then there's a third carboxylic acid that will react with it. So basically, the ratio is that this will react with how many NaOH? It will react with 3 NaOH, right? So this is how many moles? This is 0.005 moles. According to the question, it's got 0.005 moles, and this would be 3 times that many. So it's going to be 0.015 moles, right? Is that clear? 1:3. And you're given the concentration as well. So you know the moles, you know the concentration as well. That's 0.4 mole per dm cube.
Getting 37.5 centimeters.
So you can find the volume. Concentration is moles is concentration times volume. So moles divided by concentration. That's 0.4. What do you get?
37.5 centimeters cube.
You're going to get 37.5. So,
So
here,
isn't the concentration for NaOH and not citric acid?
So I took it as the concentration of NaOH. For citric acid,
please explain that again?
See, they gave you the moles of citric acid, right? 0.005 moles, right? Did you understand that it requires 3 NaOH, right? One of this requires 3 NaOH, so it's 1:3.
How do we know there's 3? Oh, okay.
Okay. So let me 1 second. I'll try and let me clear this 1 second. I said try and I said no, that's a problem. The question is just 1 second. And make sure your question is like not inverted when you send it, or rotate it if you. Okay, I can't do it on WhatsApp web. I can't rotate it. So this one, you've got this question. You've got 1.15 grams of a metallic element reacts with 300 cm cube of oxygen at 298 kelvins to form an oxide which contains. So an oxide is getting formed. Let's start with the first one. Let's start with calcium. So what's the equation? Calcium reacting with oxygen to form an oxide, where the oxide must be -2, right? That's what the metallic element reacts with oxygen. If I balance this equation, it's going to be 2, and 1, right? So it's 1.15 grams of this. So I'm going to try and figure out if the data matches with this equation. So how many moles is 1.15 grams divided by the AR of calcium, which is.
Sir, is this not a PV and RT motion?
It's not a PV0 NRT question because they're not asking. It's not
What if calculate the number of moles first?
for what we are doing that. We are trying to calculate the number of moles because you don't need PV0 NRT because this is room temperature. So you can use 24 dm cube to find out the moles of oxygen because that's room temperature, right? So how many moles is calcium?
0.02.
So that's 0.02 moles, right? So the moles of oxygen would be half of that. That's going to be 0.01 moles, right?
Is it 0.03?
What is it?
0.028.
Make it up till 3 significant figures. What's 28 and what?
287.
So you can make it 287. So this would be half of that. What is half of that?
0.0143.
0.143 moles. Now, if I multiply it by 24,000 cm cube, I'll figure out the volume. What volume do I get?
344.
344?
0.34.
The cm cube or dm cube?
dm cube.
Or 344 cm cube, right?
Yep.
So you're getting 344. So this is wrong because in the question they stated that it reacts with 300 cm cube. So it's not reacting with 300 cm cube. So the first option is wrong. Now the problem with this question is that you would have to try each option one by one, and then you'll try and figure out who reacts with 300 cm cube. That's the question. So the answer for this one is actually, I think it's D. Like if you react sodium with oxygen, it's going to form sodium oxide. And if you try to balance it, it's going to be 4Na. Figure out the moles of sodium, 1.15 divided by the AR of sodium, which is 23. How many moles do you get?
Zero point zero five.
So the moles of oxygen would be 4 times less. That's going to be 0.0125 moles, right? Multiplied by 24,000 cm cube, you'll find the volume in. What do you get? You get 300 cm. So that means this is the correct option because they said that 1.15 gram of a metallic element reacts with 300 cm cube. So this is the one. Okay, so that's how you're going to.
You're saying that we'll have to make equation of all 4 of them.
You can't even make a general equation because everyone has a different equation. Like calcium has a different equation balanced differently. Sodium has an equation which is balanced differently. So every time, the only way to solve this. Which one?
So, sir, when potassium would react with the oxygen, it would have formula KO.
K2O. Jana, the only issue over here is I don't understand how PV0 NRT is going to work because this is a metallic element that's a solid. So PV0 NRT is not for, you can't find out the MR of the metallic element, it's a solid, because PV0 NRT is for gases. Is that clear? So you can't use, you could have used, if this was a gas and they've given you the mass of a gas and the volume of the gas and the temperature and the pressure for a particular gas, then you can obviously use that. But this is a metallic element, that's a solid. So you can't use. So let's move on to the next one. Just 1 second. And just make sure if you have sent me the questions this way, try and correct this. TK, it would be a lot harder for me. Which question in this one?
Sure, all of them.
Starting. So let's start with the first one. So now the first one is, there's a washing powder. It's got sodium hydrogen carbonate, Na8CO3, right? what happens to it? It's one of the ingredients. In a titration, 1 gram of this washing powder. So I'm assuming this is impure because he's calling it washing powder. So it obviously contains, because at the end of the day, he's asking for the percentage by mass of sodium hydrogen carbonate. So that means this is actually not 1 gram. It's the impure 1 gram, right? So it requires how much, what is it reacting with? It's reacting with sulfuric acid. Make the equation. What happens when a carbonate reacts with sulfuric acid? It's going to be, what is it going to be? It's going to be sodium sulfate
NaHSO4
plus H2O plus
Carbon dioxide.
Carbon dioxide. If you balance it, it's going to be, I think that's it. You just put 2 over there. That's, I guess it is balanced. Now, this is 1 gram. And remember, it's impure, so you can't use this in the formula. For sulfuric acid, can you figure out the moles? The volume and concentration is given. That's seen to be, that's 0.1 mole per dm cube multiplied by the volume, which is 7.15. That should be in dm cube. So divide by 1000. How many moles is that?
So what about the hydrogens and NaHCO3? How are they balanced?
They're also balanced. It's 2H, 2H's, that's 4H, right? So I guess there's going to be 2H. There's going to be 2 H2Os, right?
7.15 into 10 raised to power minus 4.
And just 1 second. There's going to be 2 carbon dioxide as well. Now I guess it's balanced. So how many moles do you get for this?
7.15 into 10 raised to power minus 4.
So you're getting these many moles for this. Now 7.15 into 10 to the minus 4 moles. The moles of this would be half of that. What's half of that? 7.15 divided by 2.
3.575 into
So
10
that's
raised to power minus 4.
575 into 10 to the minus 4 moles. Multiplied by the MR, which is CO3, that's O3, that's 16 into 3, that's 48. Plus 12, that's 60. And 24, 84, right? So multiplied by the MR. What is the mass that you're getting for this?
0.030.
0.030, right? So you're getting 0.030 grams. And the washing powder mass is 1 gram. So what's the percentage by mass? It's multiplied by 100, right? So out of this 1 gram, you only had 0.03 grams of sodium hydrogen carbonate. So you multiply by 100 and that gives you 3%.
Yes.
Because that's 3%. So next one, let me clear this. So now, second.
Excuse me, sir.
Yes.
Sir, have you done 2022 specimen paper?
We've done that. February, March.
Sir, can you please send me the link?
I'll
Like
send it. I've sent it
like
in the group. It was done yesterday, I guess.
Okay, thank you.
Actually, this one, this question. The percentage composition of the atmosphere on 4 different planets is given in the table below. Density of a gas may be defined as the mass of 1 dm cube of the gas at STP. Which mixture of gases has the greatest density? So the idea is that, what is density? Density is mass over volume, right? Now, all gases, they occupy the same volume. Like 1 mole of any gas, it occupies the same volume. That's 24 dm cube. So who's going to have the greatest density? The one that has the greatest mass. Is that clear? Because all gases, they occupy the same volume at the same temperature and pressure, right? So who's got the greatest mass? Whose atmosphere has the greatest mass? No need for calculations by just looking at it. Whose atmosphere is the heaviest?
Would it be Saturn?
Uranus.
I guess it's this one because helium is the heavy one, methane is the heavy one, hydrogen is the light one. So methane is 16, right? Helium is 4, hydrogen is 2, right? So this one has the greatest percentage of methane as well as helium. So I guess this is the heaviest. It's going to be D. I mean, you can, if you want to do the calculations, you can figure out the average. How do you figure out the average? It's remember this. I mean, without calculation, it's going to be D. But the way to figure out the average mass is, how do you calculate the average of isotopes? It's the percentage multiplied by the isotopic mass. We're going to do the same thing. It's over here. Percentage multiplied by the mass of the gas or the MR of the gas. So you can do that. It's 82.5%. I'm doing it for D. That's divided by 100 into what is hydrogen? That's 2 plus helium is 15.2% divided by 100 and into 4. And then the last one, that's methane, 2.3% over 100 into 16. So if you have time, you can sort of do that, but there's no point of doing that. I mean, you can directly see. Yes.
Sir, why is it not C?
Wait a second. My question is, the reason it's not C is that C has a, remember who's got the greatest density, the one that has the greatest mass. So methane, there's very little methane and there's very little helium. If you compare it with D, there's a lot more helium and a lot more methane. So if you have heavy gases, obviously the atmosphere is going to be denser, right? Is that clear? Because I told you that mass over volume, for gases, the volume is always the same. 1 mole of any gas occupies the same volume, but they all have different masses. So the density of a gas only depends on the mass because all gases, they occupy exactly the same volume. So anyways, the last two are probably easy. I think for this one, it's D, 74.2% of sodium. So it's sodium oxide, right?
How do we write sodium carbonate?
It's Na2CO3.
Na2CO3.
Okay. Now sodium oxide is what's the percentage of sodium in sodium oxide? That's there are 2 sodiums, 23 into 2 divided by the total, which is 23 into 2. Plus there's an oxygen as well, 16 multiplied by 100. So you're going to get, I guess you're going to get 74.
Sir, don't we write it as NaO since oxygen also has a negative 2 charge and
Na is plus 1,
charge.
oxygen is minus 2, right? So the answer for this is D. So then the last one is kind of the same as well. You can try and do this 54.1% by mass of calcium. So just a second. So any other question? One second.
ऊपर वाला बस.
ऊपर वाला? नहीं कौन सा वाला?
Sir, D.
सर ये कर लेते हैं अभी, ठीक है. हाँ जी, yes.
सर आप वो वाला कर सकते हैं फरवरी मार्च के अंदर क्वेश्चन 3 जो था.
एक सेकंड, let me open it. February March questions. February March, recent one. Which one?
Yes, sir, recent जो 1-2 हुआ था वो 2022 का.
I did it actually. P underscore 1-2, right? 1 second. As a question, what question 2, right? Achha, this one we did this in class, right? So this one was this one. You got question number 3, right? Question the CHO. We did this yesterday. Now 2 grams of X. I'll just quickly go through this one. So you had So you had 2 grams of X, right? And this X was producing what? 4 grams of carbon dioxide, right? 4 grams of CO2, and it was also producing 1.63 grams of water, right? And you had to figure out the empirical formula. And you had no idea what the third thing was. So the compound had 3 things. It had carbon, hydrogen, and oxygen. Now, can you figure out the mass of carbon in this? How do you figure out the empirical formula? If you are given the mass of carbon and the mass of hydrogen, and you're also given the mass of oxygen, right? You'll be able to figure out the empirical formula. So you're given 4 grams, that it's producing 4 grams of carbon dioxide when you burn it. So all the carbon is coming from X. How much carbon is that? Can you figure out the mass? So what's the percentage of carbon? That's 1 carbon out of 44. I mean, that's
So won't you use like an equation to solve this?
No, there's no point of using the equation because you have to figure out the mass of carbon and the mass of hydrogen and the mass of oxygen to figure out the empirical formula in this case. Is that clear? The equation will not work because you don't know. The equation will work for carbon and will work for hydrogen, but no information is given about oxygen, right? So you won't be able to figure out the mass of oxygen based on the equation. Okay, we did try that, but the equation failed because you can't figure out the mass of oxygen because there are 3 things in this. The first thing, how much carbon is there in the carbon dioxide? That's 12 out of 44. That's the percentage of carbon in carbon dioxide. And you're going to multiply it by 4. So what are you getting? So you're getting need 3 significant figures. What is 1.1 watt?
But it's actually 1.0909. So
Let's take it at 1.1 grams. Water, how much hydrogen is present in this water? That's 2 out of 18, right? And multiplied by 1.63, right? What do you get?
So it's 0.18.
So why you are multiplying 2 over 18 to 1.63?
Oh, one thing I'll tell you. What's the answer for this? 0.18. 18. I said, now listen, he's asking for the empirical formula, right? And he's saying that there is a compound of carbon, hydrogen, oxygen. How do you find empirical formula? If you know the mass of this thing, right? That's it. The mass of hydrogen and the mass of oxygen. That's how you figure out the empirical formula. Is that point clear? The first thing.
Yeah.
Okay, now, so you need the mass of this, you need the mass of this, you need the mass of this. Now, what he said was that when you burn this thing, it produces 4 grams of carbon dioxide. So where is all the carbon coming from? It's coming from X, right? So I'm going to try and figure out what's the mass of carbon in 4 grams of carbon dioxide, because all that carbon is coming from X. So I'm going to try and figure out the percentage of carbon. That's 12 out of 44. 44 is the MR. And in this whole molecule, there's only 1 carbon. So 12 out of 44 is the percentage. I'm going to multiply it by 4 grams. And I will know that the molecule contains 1.1 grams of carbon. Is that point clear? And
yes.
Similarly, he's burning this molecule and he's producing water from it. Where is all the hydrogen coming from? The hydrogen is coming from this X. So I'm going to try and figure out how much hydrogen do I have. So I've got 1.63 grams of water. So the point is, what's the percentage of hydrogen in water? That's 2 out of 18. 18 is the whole MR, and out of it, there's only 2 hydrogens. The MR, or the combined AR of the 2 hydrogens, is 2. So 2 out of 18, that's the percentage of hydrogen in this thing. I'm going to multiply it by 1.63 grams. So I'll get the mass of hydrogen. Is that clear?
Yes, sir.
And the last thing is, how do I figure out the mass of oxygen now? Because they told us that the molecule also has oxygen. So how do I figure out the mass of oxygen? Like, I'm going to do it over here. Sorry. So I figured out carbon, I figured out hydrogen, I just need to figure out oxygen.
Minus from 2.
Okay, so I've got 1.1 grams, I've got 0.18 grams of hydrogen, and I need to figure out oxygen. So they told us that the whole thing has a mass of 2 grams. So I'm going to subtract from 2. What do I get if I subtract from 2?
0.72.
So I'm getting 0.72 grams. Now I can figure out the empirical formula. What's the method of finding empirical formula? Divide by the AR first, that's 12. This divide by 1. This divide by 16. So what do I get for the other two?
0.09 for carbon.
So that's 0. And this one is what? 0.045. And then divide by the,
Yes, 0.0.
so then divide by the smallest to figure out the whole number ratio. Divide everything by 0.045 and you'll get 2 and you'll get 4 and you'll get 1. So it's C2H4 and O1. That's going to be C.
Yeah.
Yes.
So in this type of question, like what is the method of approach? Like, do you have to always solve like these?
Nee, this is a difficult question, TK. Now if they hadn't talked about oxygen, TK, let's say the element did not have oxygen, right? Then I could have used an equation as well, that I knew that X was burning with oxygen, right? And it was producing carbon dioxide and H2O. And I figured out that the moles of carbon dioxide were, how many moles was this? This was 4 divided by 44. And this was 1.63 divided by 18. I could have figured out the ratio and I could have figured out the carbon and hydrogen ratio in the molecule, right? The problem came because I also needed to know the mass of oxygen as well, which is why I had to do it this way. Okay?
Okay. Yes, sir. Thank you.
So next one, just 1 second. So I'm going to do these questions now just quickly. So we've got this question and it says, make sure when you're sending questions, make sure they're like in landscape. I mean, they're straight, like not vertical. I don't have a rotate option over here. Now, X, Y, and Z are 3 isomeric alcohols. So you got 3 isomeric alcohols. 2 or more of these alcohols react with mild oxidizing agents. So they're undergoing mild oxidation. So mild. One of these alcohols, when dehydrated, will give a pair of cis-trans isomers with the molecular formula C5H10, which way is correct? So who's going to react with mild oxidizing agents out of all these 3?
Alkene.
The alcohols, which one will react with mild oxidizing agents? He's talking about K2Cr2. The first one, what is the first one? A primary alcohol or secondary or tertiary?
Primary.
Yeah, so it will get oxidized to a carboxylic acid. What is the second one? Primary, secondary, tertiary?
Secondary.
Okay, that's a secondary. What about the third one? I mean, focus on this.
Tertiary.
Okay, that's a tertiary because it's got 3 carbon chains. It's got C with an OH in brackets, 2 CH3 branches, and then it's got another CH2 CH3 at the end. So it's a tertiary alcohols don't get oxidized. So the answer for the first part is it's going to be X and Y only. And just a second. So what about the next part? Which will be dehydrated and will give a pair of cis-trans?
Y.
So Y will give you, let's try Z first. Will it get dehydrated? It will, right? But will it give cis-trans? The OH will be lost and you'll have a double bond over here, right? Will that be cis-trans?
No.
It's not going to be cis-trans because the carbon has 2 CH3 groups, right? So that part is not going to be, it's not going to be cis-trans. Or the other option is that the double bond is on the left side. But then again, it's not going to be cis-trans because the carbon will have 2 H's and you can't I mean, there's no point switching their position. So in all cases, Z is not going to. Y will, because if you draw Y is this one. It's already, I think, drawn. The OH will be lost, and you'll put a double bond here. The OH will be lost, and the H is lost from the neighboring carbon atom. This carbon will make cis trans because it's bonded to two different groups. This carbon will also make cis trans because it's bonded to two different. This one is also bonded to two different groups. So Y is correct. What about X? Will it make cis trans? I mean, it's going to be, there's no other option. Y. TK, is that clear?
Yes.
So then next one is, okay, we've got an organic compound Z is oxidized by a potassium magnate 7, reacts with sodium to give hydrogen. What could be compound Z? So who reacts with sodium to give hydrogen?
Alcohol.
And carboxylic acid. Okay, so alcohols and carboxylic acids both. Huh.
So carboxylic acid only reacts with like
carboxylic acid reacts with everything. All
sodium carbonate.
Metals.
Metal
Sodium
bases.
carbonate, sodium hydroxide.
It reacts with everything. It reacts with metals, with bases, with carbonates, everything. Okay. I mean, this is carboxylic acid reacts with sodium. They would react with NaOH. They would also react with Na2CO3. They would also react with ammonia. So carboxylic acids are complete acids. They would have all types of reactions. So now this one, what's the answer to this one? It is getting oxidized as well.
It would be an alcohol.
B.
Or so it can't be B because that's an aldehyde. It can't be D because that's a ketone. So you've got a tertiary alcohol and you've got a secondary alcohol.
Can
This
be
one is
alcohol, not oxidized. C.
Okay, so it's going to be C because it's going to be oxidized. Tertiary alcohols, they don't get oxidized. So next one, you've got I think we already did this one. Just a second. I'm going to ignore this one for now. So now we've got this molecule, and he says ethane dioic acid reacts with ethanol in the presence of a few drops of concentrated sulfuric acid. So ethane, this molecule over here, is reacting with ethanol. So it's a double carboxylic acid. If you look carefully, it's got a acetyl bond over an OH over here. It's got a acetyl bond over an OH on the other side as well. So it's got, so it's capable of forming so it's capable of forming two carboxylic acids. And Saad, iske bigger format, I'll do this one. So this one has two carboxylic acids. And it's reacting with ethanol. So the ethanol would be CH2CH3 and OH. There's going to be an ethanol that will react over here as well. The OH and H will be lost. OH from the carboxylic acid, H from the alcohol will be lost, and they would form an ester. So I'm going to remove this. The OH is lost and the H is lost, and I'm going to connect them together. And that's my molecule. That's the molecule, that's the ester that's going to be produced. So the question is, which one is the correct option now?
B.
So it's going to be CH3, CH2O, and then CO. So CH3, CH2O, and then CO. So, and then you have CO and then O. So CO2, CH2, and CH3. So it's going to be B. I'm ignoring this one. So, Acha, whose question? Can you just one second? If you have sent me questions, can you just like send a question mark so that question comes on top. So now, who gives a red precipitate with fillings?
Aldehyde.
So you're basically talking about an aldehyde. So this molecule, whatever this is, it's got to be an aldehyde. It's got to have serial bond over an H. So you have to figure out the total number of structural isomers for an aldehyde that has this one. So you got 5 carbon atoms. The 5 carbon atoms, that's 1, 2, 3, and 4, right? So that's one way of arranging, and only structural isomers. TK, be careful with this. So how many other ways can you do that? Next one would be serial bond over an H. So I can have 3 carbon atoms, and I can put a carbon chain. They're two positional. There's going to be a serial bond over an H, and I can put the carbon over here, right? Or what else can I do? I can have serial bond over an H, and I can have 2 carbon chains, right? So I guess those are the only 4 possible. I've drawn 4 of them. Right, there's an aldehyde with 5 carbon atoms in a line. There's an aldehyde with 4 carbon atoms in a line that will have 2 positional isomers, 1 carbon over here, and then there's going to be a carbon chain on the next carbon atom. And then there'll be a carbon with 2 carbon chains. That's the 4th one. Okay. As in, next one. Okay, you've got this molecule. And they're asking how many isomers exist for this one. And he's saying the unsaturated, this thing can display geometric isomerism. So I'm guessing he's only talking about geometric isomerism, that's it. So how many, no structural, nothing else. The question is entirely about geometric isomers. So how many cis-trans isomers are possible for this one? The first one, is this double bond going to exhibit cis-trans?
No.
That's not going to do that. That's not going to do that, right? The middle one, is this going to form cis-trans?
Yes.
So double bond over here is going to form cis-trans, and the double bond over here will also form cis-trans, right? So how many different cis-transes would you have in this case?
4.
So there's going to be 4. I mean, the first one would be cis. I mean, this double bond over here. And this would also be cis. The first one would be cis. The second one could be trans. The first one could be trans, and the second one could be cis, or both of them could be trans. So technically, there would be 4 versions, but 2 of them are exactly the same. Which 2?
Cis and trans.
Remember for symmetric alkenes, this over here is a symmetric alkene. For non-symmetric alkenes, the formula is simply 2 to the power n, which is that if you have 2 double bonds that are forming cis-trans, 2 to the power 2 is going to give you 4. Because the first one would be cis, the second one could be cis, this first one is cis, the second one is trans, trans, cis, trans, or trans, right? So there would be 4 combinations, but now it's a symmetric alkene. For symmetric alkenes, 2 to the power n does not work because Left to right, if you look at the molecule right to left, it's exactly the same. So which means cis trans and trans cis would be exactly the same because the molecule is symmetric. So if the first one is cis, the second one is trans, is the same as the first one being trans and the second one being cis. Because if you flip it around, the molecule looks exactly the same left to right. So there would be 3 versions of this. Is this clear?
Sir, could you please do the question at the top as well?
Okay, I'll do that. Is this one clear?
Yes.
So now, just a second. So the top one, you've got. Can you guys see? Oh yeah. So there's a compound X. So there's a compound X in period 3. Compound X reacts with, I guess that's water, to give an acidic solution. What could be the first one? Who's going to make an acidic solution out of all of these? It's going to be C or? They're the ones that are going to make acidic solution. Yeah. Because the first 2 are, this one does not dissolve in water. This one is slightly basic, it's pH 8. MgO is not very soluble, so the pH would be very slightly alkaline. So that was the first part. It reacts with water to give an acidic solution. And then he says the solution is prepared. Now we have to figure out between P4O10 and SO3. So he says that 0.1 grams of each. So this is 0.1 grams. This is also 0.1 grams. And it reacts with an excess of water. This solution is neutralized by NaOH, right? 25 cm³ of NaOH. So basically we need an equation for NaOH. So can you tell me P4O10 reacting with NaOH? What is the salt that's going to be produced? And I told you, what do you think of P4O10? Like, which acid do you think of it as?
Phosphoric.
Take it. HCPO4. Remember, when you have P4O10, think when you're supposed to make an equation out of it, think of it as phosphoric acid. So think of it as H3PO4 reacting with NaOH. So it's going to produce a salt which is Na3PO4, and it will produce water as well. So think of this as phosphoric acid. You would have to balance this. So 4 phosphoruses. There's going to be 4 phosphoruses and 12 sodiums. So there's 12 sodiums, right? Baki, I guess it's is everything else balanced? It's how many waters? That's 6 water, right? Does that make it balanced? I guess it is balanced now. What about SO3? SO3 with NaOH. What do you think of SO3 as when you're making an equation out of it?
H2SO4.
You can think of it. So it's going to form Na2SO4. Think of it SO3 as. Think of SO3 as H2SO4, and there's going to be water, right? And you can balance it to NaOH, and I guess it's balanced. So how many moles of NaOH is this? 25 into 0.1 divided by 1000. That's 2.5 times 10 power minus 3 moles, right? So 2.5.
Yes.
Okay, 2.5 times 10 power minus 3 moles, right? So now you basically have to figure out, so the moles of SO3 would be half of that, right? It's going to be 1.25 times 10 power minus 3 moles. Is that clear? And you can multiply it by the MR, which is 32 plus 48, right? 16 into 3, that's 48. Do you get 0.1 grams of X? Because they told us that it's going to be 0.1 grams.
Yes, 0.1.
So the answer is SO3, right? You can do the other one as well, but that will not give you 0.1 grams because divide this by 12, it's 12 ratio 1. So it's going to be 2.5 times 10 to the power minus 3 divided by 12 and then multiplied by the MR. That's not going to come out to be 0.1. Okay. So D is the answer. Once. As the next one is so there's silver nitrate. There's one question left. After this, I'll do the other questions. Now there's silver nitrate. It's added to a solution of halide and aqueous ammonia is then added. The ionic equation for the two reactions. So this is the precipitate that is formed, and the precipitate AgX then dissolves in NH3. Which statement is correct? They didn't tell us which halide it is. Yeah.
As it dissolves, right?
He's saying no, they didn't tell us whether this equilibrium lies to the right or to the left. Is that clear? I mean, maybe it's the equilibrium is lying to the left, and maybe it dissolves very little, right? So we can't really tell. They didn't tell us any information about the position of the equilibrium.
But iodine doesn't dissolve at all, right? So it's either going to be chlorine or bromine.
This one, no. Remember, when something is not soluble, that does not mean that it's absolutely not soluble. Is that clear? Because it depends on the equilibrium position. When they say something is not soluble, that means the equilibrium. Let's talk about calcium carbonate. We know that calcium carbonate is a solid, doesn't dissolve. But in reality, if you take chalk, a very, very tiny amount of it will dissolve. It will dissociate into calcium ions and carbonate ions, right? But the whole point is that if you write an equilibrium reaction, what that would mean is that the equilibrium is completely shifted to the left. That the amount of calcium ions and the amount of carbonate ions, that's very, very little. Very few ions are produced. Is that point clear? So the point is, they haven't really told us whether it's dissolving or not. They just told us an equilibrium reaction. We don't know whether the equilibrium is shifted to the right or is it shifted to the left. Is that clear?
Yes.
So now they're saying, now they're talking about the position of the equilibrium one lies to the left when X is, so when X is iodide, right? Iodide. Equilibrium one, will the position lie to the left or will it lie to the right? When you have iodide and you add silver ions, does a precipitate form or does it not form? With it forms. You do get a yellow precipitate, right?
Yes.
So that means the equilibrium is shifted to the right. That means you are getting a yellow precipitate, right? I mean, that is the test for iodide. Is that clear?
Yes.
So okay, so that basically means the first one looks to be wrong because it does not lie to the left. If it lies to the left, then no precipitate should form, but there is a precipitate forming. Increasing the concentration of ammonia causes the position of equilibrium one to move to the left.
Yes.
Increasing the concentration. Firstly, ammonia has nothing to do with equilibrium number one, right? What will ammonia do? Ammonia will, increasing the concentration of ammonia. Ammonia is going to affect which equilibrium? It's going to affect this equilibrium, the second one. Where would this equilibrium shift if you increase the concentration?
Right.
Towards the right.
Forward.
So it's going to move forward, right? So what will happen to the concentration of silver ions? Increase or decrease?
Decrease.
So it will decrease. So that means it will decrease in the first reaction as well. Because the concentration of silver ions will decrease, right? Because you're adding ammonia. So in the solution, all the silver ions will move to the right, according to equilibrium number two. So the concentration of silver ion will decrease. Where would the equilibrium one move if the concentration of silver ion decreases?
Left. Backward.
It's going to move to the backward side, right? So understand this, that equilibrium number two is kind of indirectly affecting equilibrium number one. you're increasing concentration of ammonia. When you do that, the equilibrium moves to the right. That means in the solution, the concentration of silverine decreases. And if the concentration of silverine decreases, the first equilibrium would move to the left. So he's saying that position of equilibrium number 1 moves to the left, which I think is right? Is that clear? And that is one of the reasons why the precipitate dissolves, because the solid precipitate, the equilibrium shifts to the left. It becomes aqueous when you add ammonia to it. Is that clear?
Yes.
So what about, but I'll check the other ones. What about C? You got Kc for equilibrium 2, it's larger when X is Cl minus 1, when X is I minus 1. So whose precipitate dissolves? Cl or I?
Yeah.
I.
No, I is insoluble. Right? So I'm going to explain why C is wrong. So I minus 1, the precipitate of I minus 1 is insoluble. Cl minus 1 precipitate AgCl dissolves, right? So equilibrium number 2 is larger. So let's talk about I minus 1. It's insoluble. That means adding ammonia will have no effect. So that means the equilibrium is shifted to the left-hand side, right? Because adding I minus 1, nothing happens to the silverines. It does not, you add any amount of ammonia, the precipitate does not dissolve. Is that clear? So that means it does not react with ammonia. So, I mean, is this first part clear, that iodide precipitates are insoluble in ammonia, which basically means that you add ammonia, nothing happens to it. You add silverines to ammonia, it does not dissolve. So it does not form this complex. It just remains, the reactants just remain as reactants. Is that point clear? So so that means the Kc value would be low, because if you take the ratio of products to reactants, there's going to be a lot more reactants. So the Kc value for I minus 1 for equilibrium number 2, we're talking about equilibrium number 2, that's going to be low. For Cl minus 1, the precipitate dissolves when you add ammonia. So in the case of Cl minus 1, the precipitate will dissolve. It's going to move to the right. It's going to react with ammonia. It's going to dissolve very quickly. So that means there's going to be a lot more products. So the Kc value would be high. So just a second. So Kc for equilibrium 2 is larger when X is Cl minus 1 than when X is I minus 1. So isn't that true?
Yes, it is.
So Kc for equilibrium 2 is larger. It is larger, right? Cl minus 1 dissolves, will react with ammonia. Iodide precipitates, they don't, so will not.
So how is B correct? Wouldn't it move
Hey,
to the
sorry. Yeah, just a second. Just 1 second. Sorry. This option number C. Remember this one. So option number C. First thing. Cl. I got C wrong. Cl minus 1 and I minus 1 have nothing to do with the Kc. Cl minus 1 and I minus 1 actually affect the first equilibrium, because they're not even present in the second equilibrium. So, I mean, the whole explanation was actually wrong. It's, let me do this again. Kc for equilibrium 2, there's an equilibrium value. Remember Kc, what does Kc change with? What is the one thing that, temperature, right? So Kc remains unaffected by concentrations. It remains unaffected. So Kc is for this reaction. This has no Cl minus 1, this has no I minus 1. The only thing that will change the value of equilibrium number 2, the Kc for equilibrium number 2 is what? It's temperature. It's not going to be changed. So I mean, the value of Kc is not going to change. It only changes with temperature. So he's talking about reaction number 2. I mean, the concentration will make the equilibrium move right or left, but the value of Kc does not change. It only changes with temperature. So that's why C is wrong. Is that clear? Is this statement clear?
Yes.
So could you please explain B and A?
The position of equilibrium 1 lies to the left if it's I minus 1. No, if it's I minus 1, you get a precipitate, right? So if you get
wouldn't that be correct?
if you get a precipitate, what does that mean? That means the equilibrium position lies to the right, not to the left. You're forming a precipitate, right? So that means it's shifted to the right. B is if you increase the concentration of ammonia. If you increase the concentration of ammonia, where would the equilibrium shift? It's going to shift to the right, right?
Yeah.
What will happen to the concentration of silver ions? It will decrease. And if the concentration of silver ions decreases, where would this equilibrium shift?
To backwards.
Backwards, right? So increasing the concentration of ammonia causes the position of equilibrium 1 to move to the left, because this one moves to the right because of more ammonia, which makes the concentration of silver ion decrease. And if that decreases, the equilibrium, first one equilibrium moves to the left. So B is right. The reason C was wrong was that I forgot that Kc only changes with temperature. That's the only thing that changes temperature. You had this reaction, and this reaction equilibrium will only change with one thing, and that's temperature. So it's not going to be larger or smaller. It's just going to change with temperature. Otherwise, it's not going to change. It's going to be a constant. Kc is always a constant. Is that clear?
Yeah.
So now, do we have another question? Just a second.
Wait, so was C wrong or was it right? The
No,
Kc one.
No, C was wrong, because Kc for equilibrium 2. Remember one thing that's very basic. C was very basic actually. We actually messed it up. Remember, Kc is something that's a constant. It only changes with temperature. So the equilibrium constant Kc for this reaction, when will it change? For equilibrium number 2, it will only change. So it doesn't really matter whether it's Cl minus 1 or I minus 1.
So is the answer B?
The answer is B for this one.
Okay, thank you.
So I guess there's one more question. 1 second. An ore of manganese contains 4% by mass of MnO2. What mass of manganese would be obtained if you've got 1 ton of this ore? So you're going to get 4% of that, I guess. Just a second. No, sorry. You got 1 ton of MnO2. And the MnO2 is, they've said that it's 4%, right? So what is 1000 kg, 4% of 1000 kg? 40 grams? 40 kgs, right? Is that clear?
Yeah.
Okay, so you got 40 kg of MnO2. Now the next part is they're not asking about MnO2, they're asking about manganese. So what is the percentage of manganese over here? I don't know what Mn is. What is Mn?
And how is it 40 kg?
They've told us that the ore contains 4% MnO2. So if you have 1000 kg, so if you have 1000 kg, 4% is MnO2. So what is 4% of 1000? That's 40 kg, right? Is that clear?
Yes.
So the next is the next part is you have to figure out what Mn is, right? So you have to figure out the mass of Mn in this. So find the percentage. What's the mass of Mn? Is it
54.9.
So you got 1 Mn 54 point, let's take it as 55 divided by the total, which is 55 plus 16 plus 16, that's 32. So that's the fractional percentage, right? And multiplied by 40 kg. I mean, it's the percentage of Mn in this thing into 40 kg. What do we get?
25.3.
25.28.
25.28,
28, which is 25.3.
okay, so it's going to be A. So here, just a second, let me so message kar do if you want your answers, questions to be on.
Sir, I don't understand how you did last part, like what you did with.
Just a second, sorry. You see, they told us that the ore has 4% MnO2. So 1 ton of the ore has 4% MnO2. So how much MnO2 do you have? 4% of this thing, that's 40 kg, right? Is that clear, this part? Now, they weren't asking for MnO2, they were asking about Mn. So what is the percentage of Mn in this thing? What is the percent? That's 55 divided by the total, right? 55 divided by the total, which is this. That's the percentage.
Sir, I texted you the question on. Did I just...
So just one second. I'm going to open the questions now. 1 second. Wait a second. I said there are 9 questions. 533. Okay, so just 1 second. So there's this one I said this one, there's a sample of HI which is warmed. I'll just quickly do this. So there's a sample which is warmed, there's 2 HI and there's H2 and I2, initial moles and final moles. So what are the initial moles? They're saying that a sample was warmed and they found that the partial pressure of HI is 28 times the partial pressure of H2. As a first thing, initially there's only HI. So if initially you only have HI, then the amount of H2 and I2 that is going to be produced from that HI, that's going to be equal, right? So if there's 5 moles and all 5 moles react, that means 2.5 and 2.5 of this would be produced according to 2:1:1, right? So these two would be produced in exactly the same quantity. So what they're saying is that the partial pressure of HI is 28 times the partial pressure of H2. So if the partial pressure of H2 is X, the partial pressure of I2 would also be X, because both of them would have equal moles and they would be exerting equal pressure. And the partial pressure of HI would be 28 times larger. It's going to be 28X. So 28 times the partial pressure of H2. So I took the partial pressure of H2 as X, and the partial pressure of I2 would also be X, because both of them would be produced in the same quantity and they would exert the same pressure. And the pressure of HI would be 28 times higher. So what's the expression for Kp? I have the partial pressures. It's going to be HI. Sorry, it's going to be partial pressure of H2 products, I2 divided by the partial pressure of HI, and that's going to be squared. And if I do that, it's going to be what? X squared divided by 28X, and that's also going to be squared. So it's going to be 1/28. What are we getting?
1.28 into 10 raised to the power -3.
Okay, so you're going to get this one.
Sir?
Haji.
So wouldn't you minus this by 28? X minus 28.
799 minus power. X minus? Listen, it's not initial. It's not initial. The mixture is already, equilibrium is established. Do you get the point? So the equilibrium is not moving forward or backward. It's not shifting. There's no initial moles. Is that point clear?
Okay, so equilibrium is already established, right?
It's already established. So you're not going to shift the moles right or left. It's already there. Okay.
So is the answer B?
Isn't it A? 28 squared. Remember 1 over 28 squared. It's squared as
What
well.
is the formula for
Oh,
partial
okay.
pressure?
I mean, the expression is the same. It's partial pressure of H2. I mean, what's the formula of partial pressure? It's partial pressure of H2 is mole fraction of H2. Mole fraction of H2 or the percentage of H2 into the total pressure.
So how come you haven't
Fraction will be-
added the equilibrium and then divided each one by the total equilibrium?
By the total equilibrium.
Yeah, because in KP reactions, you add up the moles in equilibrium and then you divide each one.
No, but
And
the
you
thing
have-
is, that is to calculate the partial pressure, right? The point is they've already done everything. The equilibrium is already established. The partial pressures have already been calculated. They've told us that the partial pressure of H2 is X. I mean, they didn't say it's X. They said that it's 28 times. The partial pressure of HI is 28 times the partial pressure of H2, right? So the partial pressure, I've already calculated it in terms of X. Is that clear?
Yeah, so what's P in this reaction? Isn't P supposed to be volume or pressure that we have to multiply it with?
So I've taken that as X, right? I've taken the partial pressure of H2 as X. They told me that the partial pressure of HI is 28 times the partial pressure of H2. So that is 28X. So I'm not doing all the background stuff because I've just taken the partial pressure as X. That's it. And the partial pressure of HI is going to be 28 times that. And the partial pressure of H2 and I2 would be exactly the same because they would be produced in exactly the same amount. So this would exert the same pressure, this would exert the same pressure. So if this is X, this would also be X. Is that clear?
Yeah.
Okay, just a second. It's so next one, I'm going to do this 1-7. I think your message still goes down a bit. 1 second. 799. 1 second. Where's this one? Today I'm going to do 799 questions. Okay. Hopefully, just your numbers are not being shared when it's.
Sir, should I send them to you personally? The one.
Send them. Just send them to me personally. That's 1 second. How do I clear this? It's clear all drawings. As I was starting with this question, we've got so there are 7-8 questions. So which the pressure is increased in the graph of PV over RT against pressure is plotted. Which graph correctly represents this result? So there's a sample of an ideal gas. So an ideal gas. No, it's not going to be B. Remember, it's an ideal gas. So an ideal gas, and it's at constant temperature, right? So that means R and T are both constant, right? So first thing, if it's an ideal gas at a constant temperature, so R and T are both constant, so they're not changing. An ideal gas is supposed to be observe ideal gas behavior. So what is PV over RT equal to? Like PV is equal to nRT, right?
Moles?
So what is this? So it's equal to the moles, right? So we have to plot. You basically have to plot moles. Does the moles of a gas in a container change? They don't change, right? There's a sample of an ideal gas, and let's say it has n moles, 10 moles, or 20 moles. You change pressure. I mean, if you have a balloon that's filled with a certain amount of gas, its moles don't change, right? Is that clear? So the moles are constant, right? So PV over RT is basically equal to moles. They're not going to change. So the answer is C. No matter what the pressure is, it's not going to change. Is that clear?
Oh, okay. Okay, sir.
Okay, so the moles are not going to change, and that's the answer. Now the next one is, one second.
Sir,
Yes.
but the pressure is like directly proportional to moles, right?
It is directly proportional to moles.
Yeah, so the pressure is increased.
Nee, but is he changing the moles anywhere? The pressure, there's a sample of an ideal gas. It's contained at a constant temperature in a gas syringe. Did he mention anywhere, is he adding more gas or is he removing gas? He didn't mention anything, right?
Yes, sir.
So the point is that the moles would remain a constant, because if you increase pressure, the volume would automatically decrease, right?
Yes.
Clear? Because remember, N is not the only variable. The temperature is also a variable, but they've kept temperature constant. So I'm not touching temperature over here. But the whole point is that the moles would remain exactly the same. So it's going to be a constant straight line. It's going to be C. It's not going to change. So next one, you've got enthalpy change of an experiment involving solutions. The mass of the solution M and temperature change are needed. What expression? It's going to be minus MC delta T, I guess.
So why
T,
minus?
why is there a minus sign? That's the question, because
If you haven't mentioned anything.
Yeah, they didn't mention anything. So I'm going to take some values. Let's say the final temperature is 50 degrees centigrade. The initial temperature is 25, right? So you started off at 25 and the temperature started to rise to 50. So if I take MC delta T, right? You've got M, you've got C. What is the value of delta T? It's going to be
25.
Final minus initial. Positive 25 or negative 25?
Positive.
Okay, because it's final, which is 50 and 25. So it should be positive 25, right? Joules, right? Is this an exothermic reaction or is it an endothermic reaction? This one.
Exo.
Because the temperature is rising, right? You started off at 25 and now you're at 50. So it's an exothermic reaction. So that means there must be a negative sign over here because it's an exothermic reaction.
Sir, but in this question, how we are able to identify it's exo or endo?
Let's do the opposite. I mean, the whole point is you're not supposed to identify whether it's exo or endo. The whole point is there going to be a minus sign in front of it or not?
Yeah, how we're getting.
Okay, so let's assume it's endo. Okay. Because my sign, if I just take MC delta T, my sign over here always comes out to be wrong. But is that clear that my sign was, if I took MC delta T, my sign was coming out to be positive, when in fact it's an exothermic reaction based on the data that's given to me. So I need to put a negative sign over here. But is that point clear that if I take this data, I need to put a negative sign over here? Is that point clear?
Sir? Sir, but it not mentions like there is an increase in temperature.
Let's do the opposite now. My whole point is, do we need a negative sign or do we not need a negative sign? Based on how he has described delta T. Okay, that's the point. So let's take it as an endothermic reaction. Let's say the initial temperature was 50. You started off with 50 initial. And now the final temperature is 25. Now, what type of reaction is this? It's an endothermic reaction, right? So if I take delta H being equal to MC delta T, right? So it's going to be mass multiplied by the specific heat capacity multiplied by delta T. What is delta T now? It's going to be, what's the final temperature? That's 25 minus the initial temperature, that's 50. What sign do I get for this?
Minus
25, right? When in fact it's an endothermic reaction, right? So what should be my sign? It should not be negative. Positive, right?
Positive.
So how can I make it a positive sign? I need to put a negative sign in front of it. So that means based on the way he has described delta T, you need to put a negative sign in front of it. because otherwise your sign would always come out to be the wrong one. Is that clear? No matter what type of data you put into it, whether it's endothermic or exothermic, the sign always comes out to be the wrong one. So you always have to change the sign. So it's better to change the sign right at the start. TK, is this clear?
Okay, sir. Yes.
That's the next one. We've got this question. Which compound on heating with an acid catalyst can produce this? It's an ester, right? So if it's an ester, the ester will break down, right? So I'm going to do just that. So the bonds over here, one second. Okay, so the ester link in the middle is breaking up. So I've broken the ester link, right? And now when I break the ester link, this would turn into an alcohol, this would turn into an alcohol, this would turn into a, is that clear?
Yes, sir.
Okay. So there are 4 more questions left in this one. Okay. So which one is the correct option? It's I'm going to draw this one. It's 1, 2, and 3. So I've got 1, 2, and 3 carbon atoms, right? And the first one has a carboxylic acid, so that's double bond O and OH. And the second one has an OH. What is the name of this molecule? That's 1, 2, 3 carbon atoms. So that's, what's the name of this molecule?
Propanoic acid.
Okay, so that's propanoic acid with a hydroxy on the second one. So that's 2-hydroxy. So the OH branch is on the second one. Is that clear?
Yes, sir. Okay.
So next one is you've got methanoic acid with HCN can both behave as acids. Okay, a solution of methanoic acid has a lower pH, and a solution of HCN, so that's got a lower pH. So more ionization for this one, less ionization for this one. Molecules dissociate more fully than HCN molecules. The first statement is true. More dissociation, it's a stronger acid. Each molecule has 2 hydrogen atoms. Each HCN only has 1. That's wrong, because that does not matter, because only one of the H dissociates, the carboxylic acid H. In HCN, there's only one H that dissociates. So remember, in methanoic acid, it's not the other H that's dissociating, it's the OHH. So only one of the H is going to dissociate. Is that clear?
So CH won't?
No, that won't, because remember, in carboxylic acids, it's only the OHH that dissociates, not the other ones. Okay, so
okay.
like in ethanoic acid, we don't care if it's got 4 H's. It's only this H that's going to dissociate.
Right.
And
okay.
And methanoic acid is a stronger acid. They've already told that it's got a lower pH. Okay. As the next one, we've got this molecule. It's an important ingredient in perfume and reacts with HCN. Which statement about this reaction are correct? A small amount of NaOH will speed up the reaction. What is the reaction? Sorry, with HCN. Do we need a catalyst for this?
NaCN.
You need NaCN, but will NaOH speed up the reaction?
No.
Remember, HCN is an acid.
HCN and NaOH react together.
Because in the previous question, we just studied that HCN is an acid, right? So they would probably react together to form NaCN. So I guess it will speed up the reaction. Is that clear?
Yes.
Okay.
Second one is also correct and the third one is wrong.
The reaction is initiated by the transfer of a proton to one of the, no, it's not initiated by the transfer of a proton, because a carbonyl group gets attacked by what?
So that
Like,
the proton is transferred to carbon.
remember in these HCN reactions. One second. So in these HCN reactions, the first step is CN-1 attacking the carbon positive. The proton comes in a lot later. A second. So the proton comes in a lot later. So the first step is CN-1.
So,
The third statement is
but in the
also
first one, it is not directly acting as a catalyst, right?
It will speed up the reaction. It is acting as a catalyst because it's going to produce NaCN.
No, sir, but like, it is not itself. It would react and then it would form.
No, but the point is whether it's not, will it speed up the reaction or not?
So, but it's reacting, it's not acting as catalyst. I mean,
the NaCN produced will act as a catalyst, so that will speed up the reaction. NaCN is the catalyst. ये जो carbonyl group वाला जो reaction है, you need NaCN as a catalyst in this. I mean, HCN is the reagent, but NaCN is the catalyst. So the first one, it will speed up because it's going to produce NaCN. That's the catalyst. And the catalyst will speed up, although it's doing it indirectly, but it will speed up the reaction eventually. The second one is wrong because the reaction is initiated when a CN-1 nucleophile attacks the carbon. And both C double bond O groups do not react because that's an ester. Nucleophilic addition happens only for carbonyl groups, not for esters or carboxylic acids. Only for carbonyl. Remember iodoform test and these, they only happen for carbonyl groups, aldehydes or ketones, not for the other ones. Okay, is this clear?
Yes, sir.
So next is both questions.
Yes.
I'll start with this one. You got structural and stereo should be considered when answering this question. Each of the following they react with NaBH4. The product of each reaction is heated with the Al2O3. So that is what does Al2O3 do? It's
reducing agent.
It's not a reducing agent, dehydrating agent. This is so NaBH4, that's reduction, then alcohol with Al2O3, that's dehydration, it turns into an alkene. Al2O3 is used to crack or to turn an alcohol into an alkene. So if we go back to the question,
reduce hoga, right?
The first part would be reduction. And then, just 1 second. The first part would be reduction, and then it would be turning into an alkene. So starting with the first one. So he's saying giving either only one isomer or a mixture of isomers, which carbonyl compound will produce the most isomers. So starting with butanol. So it will first turn into an alcohol, right? And then the OH will be lost and there's going to be a double bond over here. That's the alkene that's going to be formed. So probably just one alkene would be formed, that's it. Let's try butanone now. Butanone is 4 carbon atoms with a double bond over here. It will first turn into an alcohol. Now tell me how many alkenes will be formed. The OH will be lost. You'll get a double bond either on this side or the right side, right? Left or right. So how many different alkenes would be formed?
2, 3.
Okay, that's good. It's going to be three alkenes. 2, as you can see, there would be 2, but this one over here will also have cis and trans isomers. So there's going to be cis and trans for this one, and there's going to be one version of this. So that's 3. So I guess it's going to be B, probably. B is the answer. Pentanone is just going to give you one alkene, because the first part will be that it will turn into an alcohol, and then either the double bond is over here or over here, it's the same thing. Is that clear? Because it's symmetric.
Yes.
So you won't get a lot of alkenes. You'll just get one alkene. And that one alkene will form cis trans, but there will be just two alkenes. And the same with propanone, because at the end of the day, alcohol gets dehydrated. Alkene over here, it's the same thing. So you won't get a lot of variety of alkenes. So it's going to be B. B is the answer. There are two different alkenes, one of them forming cis trans. Is that clear?
Yes, sir. Okay.
I said, what about the first one? There's a nitrogen forms pollutant oxide Y in a car engine. So further oxidation of Y to Z occurs in the atmosphere. So I guess it's NO, which gets further oxidized to what? NO2 in the atmosphere. In this further oxidation, 1 mole of Y reacts with 0.5 moles of, so that also works out fine. Which statement is correct? Compound Z does not react further in the atmosphere.
Yes.
Does not. Does it or does it not?
Does not,
Like,
I think.
in the atmosphere, I mean, it does because it forms acid rain.
Sulfur,
In the atmosphere.
sulfur dioxide.
Yeah, but even with water rain, with water in the atmosphere, it would form nitric acid. So it forms acid rain. So I guess does not react further. What I can interpret it as that it will react, right? So I guess that one is wrong. I mean, is that clear that in the atmosphere, this forms acid rain?
Yes.
A molecule of Y has 15 electrons. That's 16 plus 14. That's, sorry, 7. That is correct. 7 plus 8. Molecule of Y. The oxidation number of nitrogen increases by 1 from Y to Z. That's wrong because it increases by 2. Plus 2 and plus 4 over here. Y is a non-polar. This is polar. There's a difference in electronegativity, so it is polar. So that's also wrong. So it's going to be B. Okay.
Okay.
So now the next one is we've got samples of magnesium carbonate are placed in crucibles RNS. The sample is heated until there's no further loss in mass. So what's happening? Decomposition, right?
Yeah.
Yes.
So it's good.
Carbon dioxide, and
That's it. And complete decomposition, no further loss in mass. Dilute hydrochloric acid is then added to both. What's the other crucible? Sorry, in R, this is what's happening in R. In S, he's not heating it, so it's still MgCO3, right? He's only heated R. And then he added what? He added hydrochloric acid. So when you add hydrochloric acid to it, it's going to form MgCl2 plus H2O. But when you add hydrochloric acid to MgCO3, it's going to form MgCl2 plus H2O plus carbon dioxide, right? So on adding, which observation is correct? In R, a gas is produced. No gas is produced. No
Carbon
gas is.
Oh, right.
He's saying on adding hydrochloric acid. I mean, the carbon dioxide was produced previously, not on adding hydrochloric acid. So no gas produced. Over here, a gas is produced. So it's going to be C. Okay? Because the question was on adding dilute hydrochloric acid. See?
Okay.
So the last one in this 1 second.
So I have a question, but like it's like I don't have a page for it. I just wanted to ask because you said that it was either CO2 or NO2 that could oxidize further, but I can't remember which one it was.
CO2, which one?
No, like it was a really previous question that you did. And I think it was SO2 or CO2 or NO2, and we had to find out which one can oxidize further in the atmosphere.
In the yeah, there was one question like this.
It gave like arc is either SO2 CO2 and NO2, and it can further oxidize. And you said
I
there was
think
a couple that
the question was that carbon monoxide doesn't really get further oxidized in the atmosphere. That was what the question was all about, if I remember clearly. NO gets oxidized, carbon monoxide, it doesn't get oxidized itself automatically. I think that was the whole question in that case. Ajay, this one again, what's the mole fraction? This is easy, I guess. It's just find the moles of all three,
Sure.
and then find the mole fraction. Haji.
So in one question, like you said, there was 15 electrons, right, in nitrogen monoxide, right?
Yeah, 15.
Yes.
8 in.
Yeah, so in that, like there was one option which said nitrogen monoxide is like non-polar, so it will be non-polar, right?
Polar. It is polar. NO. O is more electronegative. So negative side, this is positive, right? Okay. But it is polar. There's a difference in
Sure, wasn't
electronegativity.
it asking about NO2? So how does NO2?
He was asking about Y, which was NO. Not about NO2. But even NO2 is actually polar. I mean, this was the question. Where's the question? I'm not sure where the question is. But he was asking about Y, which was NO. So this one, whose questions? A second. Just put a question mark and send me the clear all drawings. Just hold on 1 second.
Sir, I have sent you a question. Can you please that?
I have just a second. I said let's I'm just randomly taking questions now. The question is about iodoform test. I previously told you that it's a methyl with a carbonyl group. The question is about whether this is going to give a positive test. It's not going to give a positive test. It's got to be methyl with a carbonyl group, not with a carboxylic acid. Remember that. Iodoform tests happen for carbonyl compounds only. So the other ones, we've got this question. It's they're saying in this reaction, which compounds act as brostolari acids? We did this one. This was 2022, I guess. In both cases, I think water was the answer, because if you look at the first one, the water loses its H. There's only oxygen left. So that means water produces H+1. So it's acting as an acid. It's the oxygen is left. Oxygen is -2, right? Oxygen is -2. So oxygen -2 loses H+1. So it's acting as an acid. And over here as well, there's water. And on the other side, there's OH ions. So water is turning into OH ions. How does it do that? It does that by losing an H+1. So over here, it's also acting as an acid. So in both cases, water is the one that's acting as an acid because it's losing H+1 ions. Is that clear? Then the next one is, this is the same one. So 1 second, let me pick another one. So now this one. This one is probably a difficult one. That not that difficult, by the way. It's a redox. equation that you have to make. Remember, electrons gained and lost should be equal. Now that's your oxidation equation. They've already given you that. A redox equation is made up of two half equations. One of them is losing electrons, the other one is gaining electrons. So they're saying that this molecule is reacting with this molecule in dilute sulfuric acid. So this molecule over here, COH, is reacting with KMnO4 in dilute sulfuric acid. So that's H2SO4. So I'm making the whole equation. The products of the reaction are carbon dioxide, water. So you're getting carbon dioxide, and you're getting water, and you're getting what are you getting? You're getting potassium sulfate, which is K2SO4. Everything is mentioned, and manganese 2 sulfate. So that's MnSO4. Now, by looking at this, that's the whole equation. That ethane dioic acid can be oxidized by KMnO4 in dilute sulfuric acid. So that's this part. The products are this, and this. So I've written down all the products. Now they've given me half of the equation, which is that they've said that ethane dioic acid turns into 2 carbon dioxide. So it turns into 2 carbon dioxides, right? How does it turn into 2 carbon dioxides? By losing 2 electrons. So I know that it loses 2 electrons because they told me when this turns into carbon dioxide, it loses 2 electrons. Is that clear, this part?
Sir, can you tell me how did you generate this equation?
They've written down everything. It's ethane dioic acid reacting with KMnO4 to form sulfuric acid. So I wrote that down, and the products are carbon dioxide, water, potassium sulfate, and manganese 2 sulfate. So carbon dioxide, water, potassium sulfate is K2SO4, and manganese 2 sulfate. So it's Mn plus 2SO4 minus 2. So is that clear? The whole equation was given. But the important part is they also told us that this thing turning into 2 carbon dioxides, this thing over here, when it turns into 2 carbon dioxides, it loses how many electrons? It loses 2 electrons. So who's gaining electrons in this equation? It's Mn over here is +7. I mean, you can find out the oxidation state. Mn over here is +2. So who's gaining electrons? Mn goes from +7 to +2. So it gains how many electrons? It gains
5.
5 electrons. So the number of electrons gained and lost, they've got to be equal. So what do? I multiply this by 2, right? And I multiply this by 5. Is that clear? So that means I should have 5 ethane dioic acids. If I multiply this by 5, I should have 10 carbon dioxides. And Mn should be multiplied by 2. So I should have 2 Mns. So this would be multiplied by 2. This would be multiplied by 2 as well. Now the rest you can kind of balance on your own now. There are 2 potassiums. So there are 2 potassiums. So that's fine. Just a second. I lost it. 1 second. Okay, so this one. So that part is fine. What's the question by there? How many water molecules? So we need to find out when 5. So we've already reached 5. So how many water molecules? That's the thing that we need to balance. So K is balanced. Mn is balanced. What's with sulfur then? That's 1 sulfur and 2 sulfurs. So that's 3 sulfurs. So I guess there's going to be 3 sulfurs over here, right? That's balanced. Make sure that's the correct one. It's 3 sulfurs, 1 sulfur here, and 2 over here. That's balanced. I'm going to balance the hydrogens now. So I've got how many H's? That's 10 and 6. That's 16 hydrogens. So how many water molecules? That's going to be 8, right? So the answer would be you need 8 water molecules. I hope the rest of the equation is balanced properly, but is this clear?
Yes, sir.
get to the next one. It's ammonium carbonate is a crystalline solid on gentle warming. A reaction occurs forming ammonia as one of the products. How are the carbonate ions behaving during the reaction? So, what's the answer to this? Ammonium carbonate. I mean, H4 is +1 CO6. It turns into ammonia. So, I don't know what happens after. So, how is carbonate behaving?
Base.
It's probably going to be behaving as a base because what's happening to NH4 +1?
Donating a proton.
Okay, so it loses a proton, right? Donates a proton. So it's behaving as an acid. So somebody is accepting that H +1, and that somebody is, you just have carbonate, that's it. So somebody has to gain that H +1. So it's acting as a base, right? Is that clear? So the next one is you got how many of the solutions shown when added to separate portion of magnesium sulfate produce a white precipitate? Now that's again about test of cations, right? Will HCl form a precipitate with magnesium sulfate? Do they form something that is insoluble?
No.
Okay, so this won't. No precipitation would happen because no combination of ions will produce anything that's insoluble. What about magnesium sulfate with barium nitrate? Will they form something that is insoluble?
Sulfate.
Yeah, the barium sulfate precipitate would be formed, right? What about magnesium with ammonium carbonate? Both of them are soluble. Will they form something that is insoluble? Magnesium sulfate with ammonium carbonate.
Magnesium carbonate.
Okay, so they would form a precipitate of magnesium carbonate because that is insoluble. What about ammonia? Will that form a precipitate? Remember, that's part of the test for cations and anions. That so that one is a part of test for cations and anions. If I can show you the tests again. One second, let me close this. So remember your, even a lot of you haven't done or given lab exams, but you got to remember the tests or at least go through them. Take a screenshot. So there are tests for cations that are given over here. Find out magnesium, right? Look at ammonia, magnesium over here with ammonia. That forms a white precipitate which is insoluble in excess. So so I guess that will form a precipitate, this one. Do you get the third one? So all three of them will form a precipitate. So it's going to be D in this case, right? Is this clear? So next is the next one in the same one, last one. The addition of NaOH to this solution produces a gas X. Will it produce a gas X? There's a reaction happening. Ammonium sulfide reacts to form ammonia to ammonium and this thing. Will it produce a gas X? will ammonium ions react with a base?
Yes.
Okay, why? Because the ammonium ions are capable of losing an H+1. And the base over here is capable of
Sir, why would ammonium ion react with NOx and why not NH3?
because NH3 is basic. Remember this, NH3 is a base. It's basic. Bases don't react with bases.
Can you
NH
explain the entire like what it's written like in the question?
See, I mean, they just told us that there's a reaction happening, right? And they told us that addition of NaOH to this solution, whatever this solution is, right? It produces a gas X, and they're asking you to identify what gas X is. So they're adding NaOH to it. That's the question. That you're adding NaOH to it, and they're asking you to figure out what that gas is. So remember two reactions. I mean, you should remember these two reactions. One second, let me. So you should remember these two reactions. The two reactions are that you've got ammonia is a base. Remember that. That ammonia reacts with acids. For example, it reacts with acids to produce NH4Cl. Ammonia accepts H+1. It's basic. It reacts with acids. On the other hand, remember that ammonium salts or ammonium ions, any ammonium salt, let's say ammonium sulfate, they react with bases. Why do they react with bases? Because the ammonium ion is capable of donating or losing an H+1 ion. So what happens is that the ammonium ion loses an H+1, it turns into ammonia. Who gains that H+1? The ammonium loses the H+1, the OH ion accepts that H+1, it turns into water. What is left? Na and SO4. So salt, water, and ammonia is produced. So the point is that ammonium ions are acidic, they lose H+1, while on the other hand, ammonia is basic. You can remember these two reactions. Ammonia reacts with acids to produce ammonium salts. Ammonium ions, on the other hand, they react with bases. So the gas that's going to be produced is going to be ammonia. Because whenever you have ammonium ion in the solution, the ammonium ion would give its H+1 to NaOH. It's going to donate its H+1 to OH ions. And it will form ammonia gas. Is that clear? Okay, then the other part. What happens when you have an addition of HCl to a separate portion of gas Y? So the addition of HCl to a separate portion of this solution produces a gas Y. So X and Y could be different gases or identical gases. What are the identities of X and Y? So the next part, so will ammonia react with HCl? Because now he's asking, it will, right? But will it produce a gas? If ammonia reacts with HCl, it produces a salt. It produces a salt, right? So that can't be the right option, although that will happen, but he's saying the addition of HCl to a separate portion of this solution produces a gas Y. Ammonia will react with HCl, but it will not produce a gas. Is that clear? So the answer is clearly not ammonia. Is that clear?
Yes, sir.
Because the reaction will happen, but the reaction will not produce a gas. So which is the gas? It's going to be H2S then, because remember you got SH ions, right? You got SH -1 ions. The solution has SH, NH4 is +1. So what would be the charge on SH? It would be -1, right? So it's going to be -1. And what does HCl do? HCl is an acid, right? What does an acid do? The acid donates an H+1. So if it gives an H+1 to it, it will form what? H2S. And they've already told you that H2S is a gas. It's hydrogen sulfide gas. So hence the option is going to be, it's going to be C. Achha, is this question clear?
Yes, sir.
Now, so we're done with this one. So next one, please send a question mark with your questions. 1 second. Vertical, don't send me vertical questions. It's can you rotate them and send them again? So meanwhile, let's do this one. Actually, I've got this question. It says, this is the same planar question. It's remember when is carbon planar? It's when it's so when is carbon planar? Sorry, I can't write this. So when is carbon planar? When it's making a double bond, right? So he's talking only about carbon atoms. So 2-methyl butene. That would be butene double bond and 2,3-dimethyl, right? So is this carbon planar? Is this carbon planar? Both of them are planar, right? So that means if I draw this molecule, it's going to look like this. It's one carbon, fan shape, trigonal planar, double bond, the other carbon atom. So it's like two fans lying flat. So there's one fan, there's attached to another fan. So they're all completely flat, completely planar. So this one is correct. The first one. Is propane planar? What is the shape of carbon atom when it's making 4 bonds?
Tetrahedral.
Okay, so it's going to be tetrahedral, but are the carbon atoms in the same plane?
No.
First thing. So let's focus on this carbon atom. It's tetrahedral, right? It's now remember in a tetra, I told you previously as well, because he's not talking about the whole molecule, he's only talking about the carbon atoms. So I told you that in any shape, 2 of the bonds are always in the same plane. Okay, if you put 2 pencils together at any angle, they can always lie flat on a table. Is that clear? The third one is coming towards you, so that's not in the plane. The dotted line is going into the board, so that's not in the plane. But 2 of the bonds in any shape, they're always in the same plane. So if you have a carbon over here, you've got a carbon over here, you're drawing propane, right? This other carbon would also be tetrahedral. This one would also be tetrahedral, and there's an H. So the carbon atoms are at least planar. I mean, the whole molecule is not planar, but the carbon atoms are planar. Is that clear?
So,
Anji.
2 carbon atoms are in plane, right?
Yes, the carbon atoms at least are in the same plane.
But still, like one is still like not in plane.
Come on, they are in the same plane. Like if you let's say you talk about this one and this one. Yeah, ye karo na ki just pick up 2 pencils, put them at any angle. Can you put them flat on your table?
Yes, sir.
So 2 bonds are always in the same plane. The problem comes with the third bond. That's not in the plane. The 4th bond is not in your plane. But in any shape, you pick any 2 bonds, they would all lie the 2 bonds would lie in the same plane. Is that clear? Okay. So in any shape.
But in the question they're asking that all carbon atom has to be in the same plane.
So these are the 3 carbon atoms. That's it. Okay. I mean, take a piece of pencil. There's 2 carbon atoms connected together, right? That's 1 pencil. There's a 109.5 angle. There's another carbon atom. Put another pencil. Can you put this shape flat on a piece of table? You can't do that, right?
Yeah.
But the rest is not planar. This is coming towards you. So this would be coming out of the board. This is going into the board. So in any shape, at least 2 bonds are always in the same plane. The third one is not planar because that's 6 carbon atoms, because I told you that in cyclohexane, you've got all of them are tetrahedral. So I told you that in a tetrahedral arrangement, you can have 2 of them in the same plane, but not the third and the fourth. Like you can't have all of them in the same plane. Is that clear? So if you have 6 carbon atoms and all of them are tetrahedral, they wouldn't be in the same plane. TK, is this clear? Because each carbon atom is tetrahedral. The next one again is tetrahedral. After that, it's again tetrahedral. So you can't keep all of them in the same plane. TK, is that clear? So, so that's the question. This is by default planar because the molecule was planar. It was trigonal planar. The molecule wasn't planar, but the carbon atoms at least were planar. And based on this logic, you can't have all 6 of them in the same plane. You can't have 6 tetrahedrals in the same plane. So let me take another question. 1 second. So this one, moving to 8686 वाले का question, ठीक है? 1 second. So this one. Now there's a compound Y which is a mild oxidizing agent. One of the products of the reaction reacts with HCN to form 2-hydroxybutane nitrile. So I'm going to do the reverse now. Butane nitrile, so CN, right? 4 carbon atoms, nitrile, 2-hydroxy. There's an OH over here. And this is CH3, this is CH2, and now this is clearly a cyanohydrin. It's got a CN, it's got an OH. And remember, it's a reaction with it was formed when you had a reaction with HCN. So it was formed, when was it formed? When you had a reaction with HCN. When you have a reaction with HCN, you have an OH and a CN attached to the same carbon atom. What is it before? What is this carbon? In what shape does it exist? Before this happened, it's a ketone or an aldehyde. It's a acetyl bond O. So that means this one over here, before all of this happened, it was a double bond O. So that means it's CH3, CH2. This carbon was a double bond O and H before the CN and OH got attached to it. Okay, this happened when you had a reaction with HCN. And before HCN, what happened? It was oxidized. So what is it? What is going to be oxidized to get you this? That's going to be a primary alcohol. So it's going to be propan 1-ol. That you had a 3 carbon atom alcohol that got oxidized. So that's the whole pathway. A 3 carbon atom alcohol got oxidized. It gave you an aldehyde, and you did HCN reaction, and it forms a cyanohydrin. So the reverse is propan 1-ol. That's the answer. So next is this clear, this one?
Yes, sir.
So next is we actually did this yesterday as well. Look at these 3 carbon atoms carefully. He's asking in this question, what is the total number of hydrogens gained or lost when this transition happened, right? So nothing happened to the rest of the molecule. Everything looks exactly the same except for these carbon atoms. Things changed for these carbon atoms, the 3 that I've marked. They underwent a certain change. And the same happened over here. This one underwent a change, and this one also underwent a change, And this one over here on the top also underwent a change, right? So I've marked the carbon atoms that have underwent a change. So I'm going to count the hydrogens. This one has 1 hydrogen. This one has all 4 bonds are intact. This one has 1 H. So what do we have about these 3 carbon atoms? This one has 2 H's. This one already has 4 bonds. This one already has 4 bonds. So what is the change that happened? You had 2 hydrogens on these carbon atoms. You still have 2 hydrogens on these 3 carbon atoms. So no change happened. No change happened to the quantity of hydrogens. The same thing happened over here. This one had, I guess it had 1 H, the 4th bond. This one had 1 H. The 3rd carbon already has 4 bonds complete. This has 4 bonds. This has 4 bonds. This one has 2 H's. So again, no change happened. The 3 carbon atoms already had 2 H's, and now they still have 2 H's together. So no change happened. So no hydrogens were lost or gained in total. Is that clear?
Yes, sir.
That's a so this is done. Just a second. So the next one is, we'll do this one. 1 second. So this one is this is about redox reaction. So a solution of sodium hydroxide reacts with 3 moles of chlorine under certain conditions. The reaction produces 5 moles of sodium chloride, 1 mole of X. And I mean, if you remember the balancing, what is the 4th product? Because I remember I told you that there's NaOH reacting with Cl2 and that's producing NaCl. And we don't know what, and there's a H2O, and they're saying that there's another chlorine containing product. We don't know what that is, right? So it could be any one of them. So they've said that there's 3 moles of chlorine and there's 5 moles of NaCl that is produced, right?
NaClO3 would be reduced.
Yeah, that's exactly, it's going to be NaClO3 because Cl is 0 and Cl is -1. So out of 6 Cls, I mean, it's going to be NaClO3 because firstly, you should remember this equation. It's, I mean, you should remember it's this equation, or if you don't, the equation will only get balanced if it's NaClO3 because Cl is 0, it goes to -1, that means it gains 1 electron. Cl is 0, it goes to +5, that means it lost 5 electrons, right? So to balance out the equation, gain and lost electrons, this should be multiplied by 5, this should be multiplied by 1. So you should have 5 NaCls and 1 NaClO3. So the question had stated that you had 5 NaCls, that you'll only get that if you have NaClO3. Is that clear?
Sir, could you please explain that again?
So it didn't mention cold or dilute, cold or hot NaOH.
But the whole thing is you're going to go with balancing, right? Let me do this again. Let's ignore.
Sir, isn't the balancing?
I mean, firstly, you should remember the balancing. That's the first point. I mean, I previously told you that with hot NaOH, the balancing is 6 NaOH with 3, because it's very hard to actually balance it during the paper. You should preferably remember it. But let's assume that you don't know what the balancing is. Okay, let's assume you don't. Huh?
Isn't it 3 NaOH and 6 Cl2?
Needs 6 NaOH and 3 Cl2s. I said, so I'm going to do this question again. And let's assume we don't know what this equation is. Okay, let's assume I have no idea what this equation is. This is what's given. That they've told us that you got NaOH reacting with 3Cl2, they already told that. And 5 moles of NaCl and 1 mole of X is being produced. So we need to figure out what this X is. X is some chlorine related compound and it's 1 mole of X. Cl is 0, it's going to -1. So that means it gains how many electrons? Gains 1 electron. Yeah. And it gains 1 electron. And there are 5 of them. So that means it's gaining 5 electrons in total. The other one should be losing 5 electrons. Because if they've told us that they've told us I said this one. They've already told us that there's 3 Cl2s and 5 NaCls are getting formed. So that means 0 to -1, that's gain of 5 electrons. Is that clear? And the other one would be losing 5 electrons. So if you start off at 0 and you lose 5 electrons, the Cl would be +5 at the end. And it's +5 only in this one. It's NaClO3. Is that clear? Saad, PVC is in your syllabus, or PVC was in O-level syllabus as well. I mean, it's better not to remember the nitrile and alkali equation. That's too hard to remember actually. But there's been one question on that.
Sir, is he talking about alkaline hydrolysis?
किस वाले में?
No, Saad. I'm talking about Saad. Is he talking about that?
No, because there are 2 equations. No? There's an alkaline hydrolysis, there's an acidic hydrolysis. Okay.
Answer?
So, I mean, there's actually been one question on this. I'll just quickly tell you what that is. Haji.
So what about dry ether like LiLH4 with nitrile? Would that be there?
Okay, ether? Ether is not in your course.
No, LiLH4 with nitrile.
No, that's not in your course. That's A2 level. Okay, that's not in your course. So send me the questions. I'll probably continue after a break. Okay? I'm going to take a break now. Okay, I'll try and send. If you're not here, I'll try and. Kisi urgent questions that like somebody has 1 second.
Sure, I think I have sent you one question.
1 second. But I'll assist 1 second. इतने ज़्यादा आ गए 1 second रुको 8683 ठीक है just a second. So let's do this one, and this one is isn't this easy? What is the concentration of hydrochloric acid? I said this one. The reason it's difficult is, firstly, find out the moles of hydrochloric acid that remain after the reaction. So firstly, tell me how many moles of NaOH were added? What is 12.5 into 0.05 divided by 1000?
(6.25 into 10 raised to power -4).
Can you repeat?
6.25 into 10 raised to power -4.
-4 moles, right? What about HCl? That's 25 into 0.1 divided by 1000. What is that?
(2.5 into 10 raised to power -3).
So who's in excess? It's 1:1, right? So 6. HCl is in excess. 6.25 will react with 6.25, right? So how much of HCl is left at the end of the reaction? This will react. So subtract how much of HCl? You added 2.5 into 10 to the minus 3, but 6.25 only react. So how much is left?
1.875 into 10 raised to the power minus 3.
So that's the moles of HCl that are left, right? How do you find concentration? What do? You divide the moles by the
Volume?
By volume in dm cube, right? So what is the volume?
12.5.
Now you remember, okay, 12.5 cm cube of NaOH has mixed with 25 cm cube. So the two solutions are together now. Is that clear? I mean, there was a 12.5 cm cube solution. So you've mixed the two solutions together now, right? Is that clear? So the new volume is now 37.5 cm cube. And that's going to be, is that clear that the new volume is 37.5 cm cube?
0.05.
Because that's going to be C. So remember this, that when you mix solutions, the volumes kind of get added up. I mean, it's harder to figure out, but it's pretty obvious that when you mix two solutions, then if you mix 25 cm cube with 25 cm cube, the new solution has a volume of 50 cm cube. Because that's the new volume. Actually, this one last. Wait a second. So then you have, hold on a second. So this one, which question in this one? Okay, how do I magnify this first thing? Anyone, which question in this one? Question number 9. Question number 10. Let's do this one. You've got we've got this one. 3.6 moles of H2 and I2 are placed in a reaction vessel, which is sealed and contained at a constant temperature. The equation for the reaction is shown. So all reactants and products, so you have to, so this one is, you have to find Kp. So H2 and I2 and 2HI. What are the initial moles? That's 2 moles and 3.6 moles. 3.6 of this and 2 of this, right? So you got 2 moles and 3.6 moles, and I guess there is no HI initially, right? So that's your initial moles. What happened after at equilibrium? 3.2 moles of H2 remain. So at equilibrium, you have 3.2 moles of H2. So how many moles reacted? You started off with 3.6. So that means 0.4 have reacted, right? So if 0.4 of this have reacted, so 0.4 of this would have also reacted, right? It's 1:1. Is that clear? So that means out of the 2, you're left with 1.6 moles now. And if 0.4 reacts with 0.4, how much of HI would be produced? It's going to be double the amount. It's going to be 0.8 produced, right? So you had 0.8 got produced. So now you have 0.8 moles. Is that clear? These are your equilibrium moles. I'm just going to repeat this one more time, that you had 3.6 they gave us that at equilibrium you have 3.2. So that means 0.4 moles are gone. They've reacted. 0.4 are going to react with 0.4. So 0.4 of this are also gone. So out of the 2.4 are gone, 1.6 is left. What do the 0.4 do? 0.4 will react with 0.4 and they'll produce 0.8 at the other side. So 0.8 extra produced. Okay? Yeah, is this clear up till this point?
Yes. So it's coming out to be.
So now the next part is how do you find Kp? Now remember one thing, finding Kp has a long process that you have to find partial pressures. How do you find partial pressure? You'll do mole fraction of this multiplied by the total pressure. But did they give you the total pressure? They didn't. In the question, there's no mention of the pressure. So how do you find Kp without pressure? So always remember this thing, that if you have a Kp question, if the moles on either side are the same, if you've got 2 moles in the products and 2 moles in the reactants, then the numerator and denominator terms get cancelled out. You don't have to find partial pressure. You can use moles directly in the expression. Okay? Because the rest of the steps, like finding the partial pressure, are going to be pointless because the numerator terms and the denominator terms, the right side, the left side, they have equal moles. So what is the expression? Partial pressure of HI. So I'm just going to take moles squared divided by moles into moles. Okay, so make sure for Kc and Kp both, if the equation has equal number of moles on both sides, you don't need to find partial pressure. You can directly use moles into the expression because all the other steps, denominator, numerator, denominator, they get cancelled out. So there's no point doing all of that. Is that clear?
So if it wasn't equal moles, then would
you
you
have
have
to-
to find the mole fractions?
Yes,
and then do it?
and then multiply the mole fraction by the by the pressure, and then put the values in the expression. Okay? You can only use this shortcut if you have equal moles on both sides, and that applies to Kc as well. In Kc, you have to use concentration, but you don't need to calculate concentration if you have equal moles on both sides. You can directly use moles into the expression. Okay, is that clear?
Thank you.
Yes.
So I'll just no units exactly. So I'll continue. I'll probably message you again if I continue, but I'll probably try and solve the questions that are sent here. Okay, maybe in 1 hour. Okay, then take care.
Allah Hafiz.
Allah Hafiz.